Good afternoon, everyone, and welcome back to the session. Hope all of you are back after the lunch break. Now, let's resume. So, guys, before the lunch break, we were trying to understand how to perform data engineering without code. In order to do data engineering without code, there were three main services available with us. First was Data Factory service, second was Synapse service, and third was Fabric service. Now, what were the differences that we learned in these services? Let's try to summarize. So we tried to perform data engineering without code just before the lunch break, and we tried to use three services for that. One was Data Factory service, second was Synapse service, and third was Fabric service. So let's talk about the differences. I'll just mention the names of these services over here first. And then we'll talk about the difference between these services. Okay. So guys, if we talk about our first point of difference, which is with respect to cost. So guys, cost wise, which is the tool that is going to be the most costly? If for the same exact task, you do that task on Data Factory, on Synapse, on Fabric, which will be the most costlier for you?
Look, synopsis.
Okay. Even as compared to Synapse, in Fabric, your cost will be even more. Okay. So as compared to as far as cost is concerned, Data Factory is the least costly option. Okay, so it's the least costly option over here. Then compared to Data Factory, Synapse will cost you more. Whereas compared to Synapse, Fabric will cost you even more. Okay, so comparatively, Fabric is the costlier option. Then coming to speed of execution. So by default, in terms of speed, obviously it depends on the backend compute that you are using. But we saw the execution time, guys. In which service was the execution done more faster?
Fabric.
Fabric, right? So here this is the
Hmm.
fastest, right? As compared to that, you will see that Synapse, I mean, comparatively, Data Factory and Synapse both will give almost same speed, almost. But generally, I have observed, generally, that's my observation, that Data Factory is comparatively slightly slower than Synapse. Okay, although on our task that we performed, if you remember, we created a pipeline. We tried to execute it in Data Factory and Synapse, and in both Data Factory and Synapse, it took around 21 seconds each. But still, in general, based on my working up till now, I feel that Data Factory is comparatively slower as compared to Synapse. Okay, it is comparatively slightly slower as compared to Synapse. Okay, then in terms of integration of source and destination locations. Integration of source and destination locations. So guys, out of these three services, which is the one that offers comparatively lesser integration? It's Synapse, right?
Synopsis.
Synapse gives you comparatively lesser integration with other source and destination services. Okay. Whereas Data Factory and Fabric up till now share the same level of integration. Okay, so even this offers high level of integration, and even your Fabric offers high level of integration. Fine. So these are the differences that we have seen up till now. Okay. With this, we'll wrap up data engineering without code. But how to do data engineering with code? In order to do data engineering with code, you have three services available with you. One is Databricks service, other is Synapse service, next is Fabric service. Let's start with Synapse service. And we'll see in Synapse if you want to do data engineering with code, how to do that. In Databricks, if you want to do data engineering with code, how to do that. Same data engineering with code if you want to do it in Fabric, how to do that. So same task we'll do. Our task will be the same. Okay, but we'll do that across different services. Fine. So let's go ahead and let's see how to do that. So I will move on to my Fabric resource, my resource of Fabric service. Here it is. Okay, now let's proceed ahead. So if you want to do data engineering with code in Synapse, you have to go to this section called develop section. Here you will be able to do data engineering with code. Whereas the below button you had to click if you wanted to do data engineering without code. Okay, but currently I want to do data engineering with code, so I'll click on develop section. Now, Synapse allows you to do data engineering with code. And in order to do data engineering with code, it gives you two type of computes. Okay. So remember when I say computes, what am I talking about is it gives you mini computers. It gives you small mini computers to execute your task. So if you want to do data engineering with code in Synapse, data engineering with code in Synapse, in order to execute your task, Synapse offers you a group of mini computers known as pool. Okay. It gives you a group of mini computers known as pool. So there are two type of pools that it offers. First is your SQL pool and second is your Spark pool. Second is your Spark pool. Remember guys that in SQL pool, you can only write code in SQL language. So in SQL pool, the only language that is supported is SQL. Whereas in Spark pool, multiple languages are supported. So in Spark pool, you can write code in SQL language. You can write code in Python language. You can write code in R language. Okay. Scala language. Like this, total around 5 languages are supported. Okay. So in Spark pool, multiple languages are supported. Then in Spark pool, there are two type of Spark pools that are offered. First is called your dedicated Spark pool. Okay, or I should mention that as my second type, dedicated Spark pool. Sorry, a dedicated SQL pool, I mean. Within SQL pool, there are two type of SQL pools that are offered. One is serverless SQL pool, other is dedicated SQL pool. Okay, serverless SQL pool, other is dedicated SQL pool. So what's the difference between the two? Let's take an example to understand the difference. So let's suppose guys, I bought a car on EMI. Okay, I bought a car on EMI. Now, if that car stays in my garage for 3 months, let's suppose I didn't use the car at all. It stayed in my garage for 3 months. Still, I will have to pay the monthly EMI cost of the car, correct? Even though I don't use it. Similarly, in your dedicated SQL pool, what happens is, even though you don't use your pool, still you will have to pay a fixed cost. Whereas, let's suppose you travel by Uber. In Uber, you only pay for the travel that you did. If you traveled for 5 kilometers, you only pay the cost for 5 kilometers. That's it. No other cost. Right? So you only pay for what you use. Similarly, in serverless SQL pool, you only pay for what you use. Okay. So this is like going by a cab wherein you only pay for the task that you do. Whereas dedicated SQL pool is like buying a car on EMI, wherein if you don't use the car at all, still you will have to pay the monthly EMI cost. Okay. Now, so as I said, serverless SQL pool is like hiring a public transport, like a cab or traveling through bus. Now, let's suppose you are traveling through public bus. Okay. So obviously you will only pay for the travel that you do. If you travel for 5 kilometers, you will uh, take the ticket for 5 kilometers and you will only pay for 5 kilometers. But once your travel is over, then do you have any rights over that bus seat? No, someone else will take it, right? Similarly, in serverless SQL pool, once your task is executed, then those mini computers no longer belong to you. They might be given to some other person. Okay. Whereas in dedicated SQL pool, okay, it will stay with you. Even though you are not doing any tasks, still those set of mini computers will stay with you. Okay. Whereas in serverless SQL pool, once your task is done, then those mini computers will be taken away from you. And when you want to execute the task again, at that time, Azure will provide you new set of mini computers to do that task. Okay. So remember in serverless SQL pool, you only pay for the task that you do. Whereas in dedicated SQL pool, even though you don't do any tasks, still you will have to pay some fixed cost. So serverless SQL pool has one advantage regarding cost. However, there is a disadvantage as well in serverless SQL pool, which is that in serverless SQL pool, you won't have any rights to write code that does changes in the data. For example, like when you travel by Uber, do you have right to change the interior of the Uber car? No. Whereas if you travel in your own car, you can change the interior. You can do whatever you want. Similarly, in serverless SQL pool, remember you won't have any rights to write code that does changes in the data. So a command like insert command will not work. A command like delete command will not work. A command like update command will not work because all of these commands do changes in the data. So commands that perform changes in the data will not work. Okay. Whereas a command like select command will work. Okay. Fine. So advantage of serverless SQL pool is that comparatively it is less costly. As in serverless SQL pool, you only pay for the task that you do. Whereas in dedicated SQL pool, even though you don't do any task, still you will have to pay a fixed cost. So that's the advantage of serverless SQL pool. However, the disadvantage is that in serverless SQL pool, you cannot run commands that do changes in the data. Okay. Whereas in dedicated SQL pools, you can run commands that do changes in the data. Fine. All right. So this was about SQL pools. Okay. Um, then as far as Spark pool is concerned, there is only one type of Spark pool available, which is your dedicated Spark pool. Okay, there's only one type of Spark pool available, dedicated Spark pool. Fine. So let me go ahead and let me show you a demo of this. So as I mentioned, in order to do data engineering with code in Synapse, Synapse offers you two type of pools. One is SQL pool, second is Spark pool. As far as SQL pool is concerned, there are two type of SQL pools. Okay. One is called your serverless SQL pool, also known as built-in SQL pool, and the other is called dedicated SQL pool. Okay. Fine. So over here, you can see your serverless SQL pool will already be configured. Okay, Azure would already know that, okay, depending on the task that you're doing, how many set of mini computers will be given for that task. And depending upon your computation time, that much cost will be deducted. Right. What about the second type of SQL pool, which is dedicated SQL pool? You can also create that. Okay, so here let me go ahead and let me create a dedicated SQL pool. Dedicated SQL pool. You can mention the size. It is in terms of data warehousing units. So whether you want 1,000 data warehousing units, 100, 200, depending on that, you can go ahead and set the size of this pool. Okay, fine. Let me create this dedicated SQL pool here. You can see the creation is in progress. Till then, let's go ahead and let's see the demo. So what I want to do is I want to show you a demo of SQL code. Okay, so let me start writing SQL code. I'll make sure that this SQL file is connected to some SQL pool, whether built-in or dedicated. The dedicated pool is still getting created. The creation is in progress. Okay, so till it's getting created, let's work with a built-in SQL pool. Remember that in your built-in SQL pool, you cannot run commands that do changes in the data. So command like create table command will not work. Okay, command like create table command will not work. Let's suppose I want to run a command that creates a table wherein one column is ID, next column is name. Okay. And you will see over here, if I just go ahead and try to run this command, it will say that this command is not supported. So create table command will not be supported. Insert command will not be supported. Delete command will not be supported. Update command will not be supported. Any commands that do changes in the data will not be supported. What about select command? Select command does not do any changes in the data, right? So select command will be supported. Okay. So let's suppose I have data inside of a file. Okay. I have data over here inside of a file. And that file inside is inside my storage account resource. Luckily, my Synapse resource is connected to my storage account resource, right? So let me read the data from that file using SQL code. Here there is a shortcut available to do the same. So I'll right click on the file and I'll say I want to read the data from this file in such a way that I get the top 100 rows in it. Okay, so over here you can see a ready-made code will be available. And this code I'm running using my built-in SQL pool. So this command is which command? Select command. Select command I'll be able to run without any issues. And you will see over here that select command will be run without any issues whatsoever. Okay, fine. Here, let me make sure that the first row in the CSV file is treated as a header. So I'll say header equal to true. Fine. Now I'll try to run this code. And now the first line of the CSV file will be treated as header or column names. Okay, fine. So the point that I'm making is in your built-in SQL pool, you can only run command that do not do any changes in the data. So create table command will not work. Insert command will not work. Update command will not work. Delete command will not work. But select command can work. Okay. So this will mostly be used by you during analysis. So during analysis, let's suppose you want to perform group by operation, other operation. You might write lots of commands for doing analysis. Maybe 50 to 60 commands people usually write in a day to do analysis. So in that scenario, you need a cost effective option because you're going to write multiple commands for doing analysis. Okay. In that case, you can choose built-in SQL pool as it is cost friendly. Okay, so that's one advantage of built-in SQL pool, but the disadvantage is that it won't allow you to run commands that do changes in the data. So insert command will not work, update command will not work, delete command will not work, but select command can work. Whereas in your dedicated SQL pool, guys, you can run any type of command. Okay, so if you connect to your dedicated SQL pool, let me go ahead and create a new coding file. By the way, in this coding file, I worked with built-in SQL pool. Let me create a new SQL file in which I'll work with dedicated SQL pool. Here we'll work with dedicated SQL pool. Okay, let me connect to my dedicated SQL pool and in dedicated SQL pool, you can run any commands like create table command will work, insert command will work, delete command will work. Okay, let me go ahead and let me show that to you. So over here, I'm trying to run create table command. This command didn't work when I ran it using built-in SQL pool, but it will work when I run it using dedicated SQL pool. You will see that in dedicated SQL pool, it will run without any errors. And you can see it ran without any errors. Similarly, your insert command will work. Okay, your insert command will work over here. Let's see if it's working. Insert. Okay. What have I done? Insert into student values like 1 and Prabhakar. Okay, fine. Similarly, if you want to add more rows, you can go ahead and add more rows over here. Let's suppose I want to add another row where student ID is 2 and the name is, let's say, Pradeep. Okay. You will see that this row will be inserted. Similarly, if you want to add more rows, you can go ahead and do that. Okay, if you want to add more rows over here, you can go ahead and do that. And you will see you will be able to run any command in your dedicated SQL pool. Fine. Similarly, let me first just show you how the table is looking like. Currently, it should have 3 rows. Okay. Similarly, let's suppose you want to go ahead and update a row value. You can do that. Okay. So let's suppose you want to change the ID of Prabhakar from 1 to 10. Okay. So from 1, you want to change the ID to 10. Then how to do that? Let's go ahead and let's see. Here it will work. That's the point that I'm trying to make. That in your dedicated SQL pool, all your SQL commands will work. Whereas in your built-in SQL pool, commands that do changes in the data won't work. Okay, but in your dedicated SQL pool, it will work. So I'll say update in student table and set the value of ID to 10, where first name is equal to Prabhakar. Let's see if that is happening. It seems that the operation is successful. Let's see whether Prabhakar's ID was changed from 1 to 10. Yes, it has happened. Similarly, your delete command can run. Okay. So that's the point that I'm trying to make, that in your dedicated SQL pool, or your SQL commands will work. Okay. Whereas in your built-in SQL pool, uh, only commands that do not do changes in the data, only those commands will work. Whereas in your dedicated SQL pool, all your commands will work. Even your delete command will work. So I'll say delete from this particular table where ID is equal to 10. Let's see if that row is deleted. So now out of 3 rows, 1 row is deleted. So we should only have 2 rows present in our table. Let's see whether we have that. Yes, we do. Okay. So fine. So this is the difference between your built-in SQL pool and dedicated SQL pool. Advantage of built-in SQL pool is that you only pay for the task that you do. Okay. Whereas in dedicated SQL pool, even if you don't do any tasks, still you have to pay the cost. So built-in SQL pool is like hiring a Uber cab, wherein you only pay for the travel that you do. Whereas dedicated SQL pool is like getting a car on EMI, wherein even though if you don't use the car, still you will have to pay some fixed EMI cost. Okay, so advantage of built-in SQL pool is that it is cost friendly, but the disadvantage is that in built-in SQL pool, you cannot run commands that do changes in the data. So insert command won't work, update command won't work, delete command won't work. Okay. So only commands that do not do changes in the data, only those commands you can run in built-in SQL pool. Whereas in dedicated SQL pool, all your types of commands will be supported without any issues. Fine. So that was about the SQL pools, right? The second type of pool that Synapse offers is Spark pool. Okay. So in Spark pool, remember multiple languages are supported. Okay, so it supports SQL language, Python language, R language, Scala language. In total, it supports 5 languages. So what if you want to work with Spark? In that case, you will first have to create a Spark pool over here. I'll call it dedicated Spark pool. Remember, as far as Spark pool is concerned, only one type of Spark pool is allowed to be created, which is dedicated Spark pool. Okay. Then you can go ahead and mention the size of the Spark pool over here. So whether you want the computers in the pool to be of small size, medium size, large size, you can go ahead and specify. Have a look over here. When I say Spark pool, pool means a group of computers, right? So here what will happen in your Spark pool is that out of the group of computers that you will choose, let's suppose you are choosing 5 computers. Out of 5 computers, one computer will act as a master computer. The remaining computers will act as slave computers. Usually what we want is we want a bigger configuration for master computer, maybe slightly smaller configuration for slave computer, right? But here we aren't able to set different configuration for master node or slave node. Here in general, you are just able to set the configuration of node, and that will apply to both your master node as well as slave node. Okay. So this is one point that I didn't like about Synapse. Whereas in the services that we'll see ahead, this point will be taken care of. Okay. So for example, in Databricks, this point will be taken care of. Okay. There you will be able to set different configuration for your master computer, different configuration for a slave computer. Fine. If you want to auto scale, you can go ahead and do that as well, where you can mention the minimum number of computers and maximum number of computers to be used. And Azure will allocate the exact number of computers depending upon your workload. Fine. Let me go ahead and let me create this Spark pool. Let me create. Fine. It has been created now. Or I guess creation is in progress. Okay. Let's wait. Creation is in progress. So it says it will take around 1 or 2 minutes. Fine. Anyways, now let's suppose if you want to use your Spark pool, although the Spark pool is getting created, you can say I've got a message that creation has completed. So that's good. Now, if you want to use it, how to do it? Let's see. In that scenario, you will go ahead, create a coding file called notebook file. In notebook file, multiple languages are supported. Okay, just like in your Spark pool, multiple languages are supported. So you need a coding file also where multiple languages are supported. So notebook file is such file where multiple languages are supported. Fine. So I'll connect this notebook to my Spark pool, and then I'll try to run any piece of code. But have a look here what happens. In the first line of code, since this is the first line of code that I'm running using the Spark pool, at that time, Azure will realize that, oh, I forgot to set up the Spark session. I forgot to allocate the master computer. I forgot to decide which will be the slave computers. Okay. All of that it will do right now when I try to execute this line of code. So at this time, it will try to set up the Spark session. Okay. Wherein it will make sure that all the backend work is ready. It has your master computer ready. It has the slave computers ready to do the task. So there's a bad point that I didn't like about Synapse, that it waits for me to run the code to set up the Spark session. So always the first line of code will always take time, even if it's a very basic code. For here, I am asking it to print this 5 characters, HELLO. Even for this simple task, it will take time. Why? Because it's the first line of code that you're in. So at that time, Azure will realize that, oh, I forgot to set up the Spark session. I forgot to make sure that all the backend work is ready. My master node is ready. My slave nodes are ready. All of that work it will do right now. It will set up the Spark session. And it will always take around 2.5 minutes to do that, which is what I didn't like. This will be taken care of by Databricks. Okay. This will be taken care of by Databricks. And Databricks, it won't wait for you to write your code. Spark session will always be on. Okay, Spark session will always be on. But because of that, Databricks will be more costly as well, whereas Synapse is less costly because it only switches on the Spark session only when it is required. Otherwise, it does not keep the Spark session switched on. Okay, fine. So over here, let's wait for around 2.5 minutes. It will take that much time to set up the Spark session. Let's wait till then. We'll wait and afterwards we'll go ahead. Let's
Smith,
wait.
I have one
Hmm.
one ask. A data
Yes.
warehouse, data lake. Where this comes into picture? Data warehouse and data lake.
Okay. So let's understand. So in simple words, okay, if I want to use this term data warehouse, what does it mean? Then the second term that you mentioned,
Data lake. Data
data
lake.
lake, what does it mean?
Yeah.
Let's understand. So for that, what I'll do is I will open a whiteboard and let's try to understand the working of data warehouse. So for that, I'll create a whiteboard over here. Okay, now let's proceed. So let's give a heading data warehouse. Okay, so in simple words, it's nothing but okay, in simple words, you can think of it as a big digital storage room where companies keep their all their important data. Okay. As we proceeded, we'll elaborate more just in the next 2 minutes. But in simple words, think of it as a big digital storage room where companies keep all their important data. So data warehouse is a central system. It is a central system that stores large amounts of data from different sources so that it can be used for reporting, analysis, and decision making. Okay. So uh, here, let's understand whether um, our Synapse is a data warehouse. Okay, then you mentioned another term which is your data lake. So, what is data warehouse by the way? It's a central system that stores large amounts of data from many different sources so that it can be used for reporting, analysis, decision making. Okay, so it can, so talking about Synapse, that can Synapse be termed as a data warehouse? Well, it can function as a data warehouse, but it's more than a data warehouse. Okay. It's more than a data warehouse. So yes, one of the component of Synapse that it's is that it acts as a data warehouse. So for example, what is the purpose of data warehouse? For storing and analyzing large data sets. In Synapse, can I use it to store and analyze large data sets?
Yes.
Yes, right? So Synapse can
Yeah.
act as a data warehouse. Then you mentioned about a term called data lake.
Lake. Hmm.
Okay. And how is it different as compared to data warehouse? Let's see. So for that, I will open another whiteboard over here. And let's go ahead and let's understand the concept of data lake. We'll give a heading here, data lake. So let's think of data lake in simple words as a huge digital water tank where you can store all kinds of data, whether it's raw format, whether it's unorganized format, okay, whether it's structured format, whether it's unstructured, anything. Just store the data as it is. So whether you have text files, your images, your video files, log files, Okay, you can store that in your raw format. Okay, so for example, um, can up till now, can you think of one tool that we have used that can be called a data lake? Up till now, one tool that we have used that can be called a data lake.
Um, in Synopsys, we can store in a file format, and I don't know.
Hmm. So as far as Azure Blob Storage is concerned, we cannot call Azure Blob Storage as typically a data lake. So some people would say that, okay, even in Azure Blob Storage, let's call it a data lake. Okay. Well, it's not actually a data lake. Okay. So it's Azure Blob Storage is basically a storage container that can hold your CSV files, image files, videos. It's like a general purpose digital locker. Whereas there is a tool called Azure Data Lake Storage, ADLS. Okay, Azure Data Lake Storage. If you just go ahead and have a look here, 1 second. I'll just go ahead and show one important thing to you. Have a look. Your Gen 2 Data Lake Storage, what does it call it as? ADLS, right? Azure Data Lake
Yeah.
Storage. This is your Gen 2 storage account, right? So it
Mhm.
is termed as a data lake storage.
Yeah.
Okay, wherein you store your data, whatever your data is. Okay, store it in a hierarchical manner. So someone would say, even Gen 1 storage, can I call it a data lake? Well, no, data lake usually has extra features. One is, well, of course, one is you can store all your type of files. That's one. So you can say that, okay, it can be done in Gen 1 as well. It can be done in Gen 2 as well. But data lake has one extra feature, which is it should allow hierarchical storage. That is folder like structure, which is there in
Yeah.
our Windows, for example. It allows us to store files in folder like structure, where in a folder, we can store subfolders and subfolders, more subfolders, and so on. Okay. So
Yeah. That's true.
correct. So now what is the difference, buddy, between a data warehouse and a data lake? Data lake is just the place where you will store data. Data warehouse is a place where you will be able to store your data and also use that data to perform analysis, whether it's historical analysis or predictive analysis.
Mhm. Okay. Thank you.
Yes,
Thank you, sir.
welcome. Welcome. All right. So let's go ahead. And what we'll do is over here, you can see I tried to show you a demo of Spark Pool. It took some time to start the Spark session. Okay, and there's one thing that I didn't like about Synapse, that it waits for me to run the code, and at that time it tries to set up the Spark session. Yeah, so I have to unnecessarily wait. So there's a thing that I didn't like in Synapse, which is rectified in Databricks. In Databricks, it will always keep the Spark session on. So it won't wait for me to run a code and then it will think to start the Spark session. No, Spark session will always be on. But because of that, Databricks is costly as well because it always keeps the Spark session on. Whereas Synapse only turns on the Spark session when the need arises. Okay, so it's like, let's suppose you have a AC in your house. If you keep it 24 by 7, if you keep it on 24 by 7, it will cost you more. Whereas if you switch on the AC only when you need it, only when you need, only when you're in the bedroom, only then you are switching on the AC, then obviously it will cost you less. So compared to switching on the AC 24 by 7, if you only switch on the AC when it's required, it will cost you less, right? Similarly, in Synapse, Spark session is only turned on when required, because of which it costs less. Whereas in Databricks, it it's it is kept on uh, it is kept on 24 by 7. Because of that, Databricks costs more. Anyways, now let's go ahead. And I wanted to show you a demo of Spark Pool, that in Spark Pool you can go ahead and write code in multiple languages. Okay, so let me go ahead and let me show you how to do that. So let's suppose I want to read data from this particular file called iris.csv. Okay, I can just right click and say I want to load the data into a Spark data frame. So it will automatically give this code. Okay. This code I just have to copy, paste in my working file, and that's it. I'll be able to go ahead and run this code. Okay. So here I'll be able to read data from this file. Once the data is ready, you can go ahead and do changes in it, whatever transformation you want to do with code, whatever transformation you want to do, you can go ahead and do that. Anyways, the point that I'm trying to make is in your um, Spark pool, you can write code in multiple languages. You can write code in Python language, Scala language, SQL language, R language. You can see multiple languages are supported here. Okay. So if you want to write code in SQL language, then choose SQL in the drop down and then write SQL command. Okay. Fine. So that's one way of choosing the language. Another way of choosing the language is by mentioning this magic command. Okay. So even if, although you're in the drop down, you would have selected Python, but still, if you want to write SQL language, then what will you can do is in your cell, you can use this magic command called percentage SQL. With this, it will understand that, okay, in this cell, you're going to write SQL language. Okay, it will learn that, okay, in this particular cell, you're going to write SQL language. So if you use this magic command, it only applies to that particular cell. Whereas if you choose your language in the drop down, it applies to all the cells in the file. Fine. Okay. So you can write code in multiple languages over here. You can go ahead and do that. Anyways, so with this, I just tried to give you an overview of Synapse. That Synapse allows you to do data engineering with code. But in order to do data engineering with code, Synapse um, gives you two type of pools. One is your SQL pool, second is Spark pool. As far as SQL pool are concerned, there are two type of SQL pools. One is built-in SQL pool, other is dedicated SQL pool. We talked about the differences between the two. In general, SQL pool only allows you to write code in SQL language, whereas Spark pool allows you to write code in multiple languages, whether it's SQL language, Python language, Scala language, and so on. Fine. So over here, I have shown you how to write code in Python language, but just to prove that in your SQL pool, you can also write code in SQL language. Let me go ahead and let me write code just to prove, okay, that you can write code in your SQL language. So in order to do that, uh, what I will do is let me see my data. What data should I work with? Should I work with this data? Fine. Let me work with this data. Doesn't matter. Okay. So let's suppose what you want to do is you want to write this, we want to write code in SQL language. So in this scenario, what I'll do is I'll write this code, say convert this to a temporary view. I'll call it iris data. Okay. Now I can go ahead and run SQL code. Okay. So if I want to run SQL code, one way is I can select from this drop down that I'm going to run SQL code. And now let me run SQL code. I can just write select star from this view called iris data. Fine. Let's see if I'm able to run it. This is SQL code, right? And you will see that I will be able to run. Okay. I will be able to run it. Obviously, here the issue is that the first line has not been treated as the first line of the CSV file has not been treated as header. So over here, I will have to make this change in the code that treat the first line of the CSV file as a header. And after that, this will work. Let's go ahead. Okay, here I am receiving an error. Let's understand what is that error. Uh, what issue am I facing? Header equal to true. This is fine. Seems fine, right? Oh, sorry. This is Python language, right? Sorry. So I will have to select in this drop down Python. Okay, fine. Let me name this view as new data view. And now let me query from it using SQL language. So make sure that if you are writing code in SQL language, make sure you select it in the drop down. Otherwise, you will get errors. Okay. So make sure you select it in the drop down. Okay. So this was just to prove that yes, using your Spark pool, you can write code in multiple languages. Okay. You can write simple code, complex code. Okay. So here my intention is to show you the capabilities, not to write more and more complex code. So I'm running simple code just for our understanding. That's all. Just so that you are aware about the capabilities of these services. All right. So this was about Synapse. Okay. Now let's go ahead and let's talk about Databricks. So in Databricks, will you be able to do the same? Well, yes, you will be able to do the same. Okay, but guys, in Synapse, if we wanted to store files, were we able to store files within Synapse? No, right? In fact, Synapse by default had a connection to your storage account resource. It had connection to whom? It had connection to your storage account resource, guys. Okay, so for example, let's suppose you want to do one change. Okay, let me think over here which change I should do. So I'm thinking that I have my Spark data frame here. Let me do one small change. Okay. And what I will say is, um, take this data frame, take the values in it and store it in a CSV file. Okay. Load it in some CSV file. And if the CSV file already exists, then overwrite the content in it. What will be the CSV file? Let me mention that. So I will say have a folder called new folder. Inside of it, have a file called new file.csv. Okay, or new file. Obviously, it will create a CSV file only. Fine. Let me run this code. So where did this where was this data stored? Was it within Synapse? Synapse doesn't have capability to store files. But if you remember, Synapse automatically connects to what? Synapse automatically connects to resource of storage account service. That too Gen 2 storage account service. If you guys remember. Okay. Synapse doesn't have capability itself to store files. So to store files, it uses a resource of Gen 2 storage account service. Okay. So remember, Synapse doesn't have its own file system. So it uses the file system of Gen 2 storage account resource. Okay. It uses a file system of Gen 2 storage account resource. So when I said that, okay, store the file in a folder called new folder. Okay. It would have done that change where? Let's understand. So remember one point, which is that your Synapse doesn't have capability to store files. So to store files, it uses it. I mean, Synapse doesn't have its own file system, like how Windows has its own file system. Synapse doesn't have its own file system. So for that, it connects to your Gen 2 storage account resource and uses file system of Gen 2 storage account resource. Okay, fine. And over here, I wanted to show you one important thing. Hmm. Okay. You can see over here, a new folder was created just 2 minutes back. And inside of it, we have our file. Okay. Inside of it, we have a file. Currently, a default name is given to it. You can obviously customize the name based on the code that you write. But the point that I'm trying to make is Synapse doesn't have its own file system, but Synapse is connected to your storage account resource and it uses the file system of storage account resource. That to a Gen 2 storage account resource. Coming to Databricks now. Now, Databricks, luckily, it has its own native file system called DBFS, which acts as a wrapper over it. Okay. So Databricks doesn't need any other file system. Databricks has its own native file system. But that system is not recommended for production purposes. Why? Because in the Databricks file system, the maximum file size, the size of, the size of one single file is should be maximum 2 GB. Okay, it should be maximum 2 GB. Whereas in your storage account resource, the maximum file size of one single file is 4.5 TB of one single file. One single file. Okay. So DBFS, so although Databricks has its own native file system, but it's not recommended for production purposes. Okay. One reason is that its capacity is less. That's one. Second is that DBFS is wrapped around your Databricks resource that you create. So let's suppose if you want to use Databricks service, you will have to create a resource of that service, right? So let's suppose if the resource gets deleted, along with that, DBFS wrapper will also get deleted. Okay. Whereas in case of Synapse, if Synapse gets deleted, will your storage account get deleted? No, they are two separate resources. Storage account is a different resource. Synapse is a different resource. So even if you delete your Synapse, still your storage account resource will stay. Okay. So what are the reasons why DBFS is not preferred for production purposes? One reason is that it has very less capacity. Second reason is that once you delete your Databricks resource, along with that, your DBFS will also go away. Second is, let's suppose you uploaded your file in your DBFS and your teammate wants to use the file that was uploaded in your DBFS. Your teammate will not be able to do that. So you will not be able to share your file system. Okay. Whereas, let's suppose on the other hand, instead of DBFS, you use your storage account resource. Okay, you use your storage account resource. Now you can use data instead of the storage account resource. Your teammates can use it. Okay, everybody will be able to use it. Fine. So Databricks provides its own native file system. So Databricks does not require help of any other external file system. I mean, it can take help, but it does not require. Okay, it has its own native file system. Although that native file system is not recommended for production purposes. And I gave you the reasons for that. Anyway, since I wanted to create a resource of Databricks service, let me go ahead and do that. So here it's asking me to put that resource in some of the other resource group. Let me give that resource a name. I'll call it webinar DB Databricks one resource. And I will create this resource with a pricing tier called standard tier. There are two main pricing tiers, standard and premium. With standard, you will only get access to Spark Pool, whereas with premium, you will get access to Spark Pool as well as SQL Pool. Okay, let me show that to you. Let me actually show that to you. So I'll create one with standard tier first, and here you'll only get access to Spark Pool. Let me create this resource with standard tier, and simultaneously, I will also create this resource with premium tier. Let me create it over here with premium tier. I'll do that. Okay. Let me create a resource of Databricks service. I'll quickly create a resource and then we'll proceed. But this time, this Databricks resource that I'll create, it will be with premium tier. Remember, with standard tier, you only get access to Spark Pool, whereas with premium tier, you get access to Spark Pool as well as SQL Pool. Let me create this second resource with premium tier. You can see their creation is in progress. So let's wait till then. Once it's created, you'll be able to see the difference between your standard tier and premium tier. Let's wait till then. We'll wait over here. Let's wait. Within a few minutes, the resources should be created. So I've created two resources of Databricks service, one with standard tier, other with premium tier, just so that you can understand the difference between the two. Let's see. The creation is in progress. Let's wait till then.
Smith, I have one ask. Can I?
Yes. Yes, yes, sure.
Uh, whatever we are doing, let us assume that in a production environment, do we have a setup for pre-production and the production? How these two components are handled in a industry?
Okay. So you mean um, the okay,
The
let me know which scenario you are talking about for production.
see, yeah.
Uh,
Suppose
hmm,
you made a pipeline and everything, and you
correct.
want make use of the production systems.
Hmm.
Then where do we test everything and where do we
Okay,
what that
okay, got
install?
it.
Yeah.
Okay, so in that scenario, what we do is what I have done, usually with my clients, what our team used to do is we used to have one separate resource specifically for pre-production. Okay.
Right.
And we used to create our pipelines over there. Then
Mm-hmm.
those pipelines we used to then export whatever pipelines you create, whether it is with code,
Mm.
without code, you will be able to
Mm.
export it. There'll be an export button. Okay.
Oh, that is
So
important.
correct. So those pipelines we used to then export in our second resource, which is a production related resource.
Mm-hmm.
So for
Mm-hmm.
pre-production, production, we used to create separate resources altogether.
Okay.
Okay.
And the QA team will involve to test the application. Is there any QA involved in this? Suppose you create a pipeline and whether exactly things are going. Who will decide that the things are going in a smoother way? QA will be involved or only ourselves unit testing, some kind of a testing
So
and okay.
yes, in for example, I worked with Accenture earlier in my career, where I worked on these services. Okay, there we had a dedicated QA team. So I mean, there was one team that was doing the live testing. They used to
Testing.
monitor the production environment. That's one. But before that,
Mm-hmm.
before it went on to production, the QA team would separately recreate another resource, and all
Mm-hmm.
the workspace items they would have exported in their own resource, and they would
Mm-hmm.
test on it. So there
Okay.
are two type of testing. One is before going into production, the QA team will test it,
Mm.
and another testing that goes
Live
which is
testing.
during live production. Okay.
Okay.
Yeah.
Live production
So
in the sense like live data they will monitor.
correct, they will monitor
Okay.
that whether everything is
A
working
production
properly or
support.
not. Correct,
Like a
production
production
support.
support. Yeah.
Right, exactly. Correct.
Thank you.
So that is how it used to be in Accenture. And similarly, other companies also would follow similar strategies.
And
Anyways,
suppose you
hmm.
released a one version exported, suppose it is not working, you can roll back and can it all the old production version will be working? Can we maintain like a or that pipelines which
Okay, so you are saying like that create versions of production. That
hmm,
is not possible with these services like Synapse and Databricks. But in
hmm.
Fabric, you will be able to do that.
Okay, so this version is working. If something
Huh,
goes wrong, then version one can be rolled back so that it will take care of.
correct, exactly.
Yeah.
That will be possible in Fabric,
Okay.
which is
Fine.
why
Thank you.
Fabric has a high demand. Yes, welcome.
Yeah. Thank you.
Correct. Yes, welcome. All right. So I was trying to create a resource of Databricks service. See that the resource with premium tier has been created, but the resource with standard tier is still in progress. That's strange. Let's see the progress again. I'll refresh the portal. The resource with standard tier is still in progress. Anyways, I wanted to show you the difference that in premium tier, you will get to work with SQL pool as well as Spark pool. Whereas with standard tier, you will only get to work with SQL. Sorry, you will only get to work with Spark pool. Okay. Whereas with premium tier, you will be able to work with SQL pool and Spark pool both. And I have my resource of premium tier already created. Resource of standard tier is not created yet, but my resource of premium tier is already created. And here you will be able to work with your SQL pool as well as Spark pool. Okay, your SQL pool you will be able to create as well as Spark pool you will be able to create. Within your SQL pool, you can go ahead and select the type, whether serverless SQL pool or dedicated SQL pool. Within dedicated, there are two options, Pro and Classic. Pro has it uses certain performance related features. So what it does is depending upon your usage up till now, it figures out that let's suppose in case of uh, let's assume what is that term called wherein the Azure decides the number of nodes, auto scaling. So in terms of auto scaling, for example, uh, it automatically decides based on your working up till now that okay, it seems for you around 4 computers in the pool work well. So going forward, it will give you that many computers. Like that, there are different performance features that it uses. Okay, earlier this pro feature was not there. Earlier we only had this classic feature available. Earlier it was not called classic. Uh, okay, it was just called dedicated SQL pool. But now that dedicated SQL pool is divided into two options. One is classic dedicated SQL pool, another is pro dedicated SQL pool. Pro is more better performance wise. Okay, but it's up to you. Okay, so just like in Synapse, you have serverless SQL pool, dedicated SQL pool. Even here you have the same. Okay, then just like in Synapse, you are able to create a Spark pool. Even here you will be able to go ahead and create a Spark pool. Okay, so but one advantage of creating a Spark pool in Databricks is that here the team that created a Spark pool in Databricks is the one is the original Apache Spark team. Okay, the team that originally created Apache Spark, they were hired by Databricks and they themselves have designed the Spark pool in Databricks. Okay, so one thing that you will see is that here the Spark architecture that will be implemented in a more better manner. So it's like this. I always use this simple analogy to make people understand. Let's suppose you have two shoe companies. One is the original shoe company called Adidas. One is the copy of it called, let's name it anything else. Okay. Obviously, the original company will be better performance wise, right? Similarly, here the Spark pool in Databricks is created by the original Apache Spark team. And you will usually observe that when the same Spark pool is run in Databricks and when the same Spark pool is run in Synapse with the same configuration, you will usually see that the Spark pool in Databricks is more faster. Okay. It's more faster in execution. That's what I've usually seen. Okay. Anyways, one major advantage of your Spark pool in Databricks is that you can share it among the members of your organization. Whereas in Synapse, you cannot do that. So let's suppose your other member of your team will in Synapse, he will have to create his own Spark pool. Whereas in Databricks, let's suppose if you have created a Spark pool now, you don't want to use it, you can share it with other members of your organization to save cost. Okay. So that's one advantage. Second advantage is that unlike in Synapse, where you could not set different configuration for master and slave computer, in Databricks you can do that. You can set different configuration for your master computer different configuration for your slave computer. Okay, master computer is also known as driver node. Slave computer is also known as worker node. It's a different configuration for it. Fine, and you can create your Spark pool. And so there's one advantage. So up till now, how many points I've mentioned? One is that in Databricks, you can share your Spark pool. Second is the Spark pool in Databricks, you will see it will be more faster in execution. So the same code when you will run in Databricks, same code you will run in Synapse, you will see that in Databricks it is more faster. That's second point. Third point is that you can set different configuration for your master node and slave node. Okay, which so that's third point. And yeah, so these are the three main points. Any other point that I'm forgetting? No, right? Okay, so these are the three main points over here. So one is that you can share your Spark pool. Second is it's more faster in execution. Third is you can set different configuration for your master and slave computer, which can affect the performance. Usually for master computer, we want a bigger size, okay, as compared to slave computer. So you can select the size as per your wish. In Databricks and Synapse, it did not allow you to do that. Then there was a fourth point I remembered right now, which is that in Synapse, it waited for us to execute up the code. And at that time, it tried to switch on the Spark session. Whereas in Databricks, it will already be switched on. Okay. In Databricks, it will already be switched on. You won't have to wait to for Azure to switch on the Spark session. No. In Databricks, it will already be switched on. Because of that, Databricks is more costlier as well as compared to Synapse. Okay, let's wait. Over here, I'm trying to create a Spark pool in Databricks. Let's wait over here. And by the way, till then, let me take care of one thing. So guys, Synapse doesn't have its own native file system, right? But I mentioned that Databricks has its own native file system called DBFS. Okay, let me go ahead and let me show to you where to see it. So you have to go to catalog option. Here you usually see this button called explore DBFS, but it's not visible to us, right? So in order to make it visible, what to do? Go to settings, then advanced option, and here you will get a field for DBFS. You just have to switch it on. And now what will happen is you will be able to browse DBFS from this catalog option itself. Okay, it's not like if you don't turn it on, then you won't be able to have access to DBFS. You can still get access to DBFS, but using with code. But what if anybody wants to explore DBFS without code? Okay, what if they want to do it without code? Then they need to enable that field that was visible. So where to see it? So they have to go to settings. Under settings, there will be advanced option. And here there will be a field called DBFS, which has to be turned on. And once it's turned on, then in the catalog option, they will be able to browse DBFS without any code. Fine. Here they can upload their file if they like. Let's suppose here I want to create a folder called sample folder. And within that folder, I want to have my file. Let me upload the same file that I've been working up till now, iris.csv. Okay, fine. So let's move forward. And now let's suppose I want to uh, read data from the file. How to do that? Let's see. By the way, I'm just checking if my Spark pool has been created. You can see the creation is in progress. So let's wait till then. You might wonder that Smith in Synapse it got created fast. Here why it's taking time. Well, in Synapse, when we created the Spark pool at that time, it didn't do the effort of starting the Spark session. Here, while creating the Spark pool, it will also switch on the Spark session. Okay, so that's why it's taking time. Anyways, the creation is now complete. Now I can create a new notebook file. Just like I did in Synapse. Here also I can create a new notebook file. Make sure that it is connected to my Spark pool and run code in it. Whatever code I want to run, I'll be able to go ahead and run code. Let me run a simple code over here. I'll say print hello. And your simple code I'm running, and you will see that this code I will be able to execute. So here, if you remember in Synapse, the first line of code took time because at that time Azure thought that, okay, now I should switch on my Spark session. But here, in case of Databricks, it's already switched on. Okay, so you don't have to worry about it. Fine. Anyways, let's suppose you want to go ahead and read data from your some file. How to do that? Let me go ahead and let me show that to you. So here, I'll just go ahead and do one thing. I uploaded my data in my DBFS. Let me get the path of that data file. So copy path. And similar code to what I ran in Synapse, similar code I'll run here as well. Okay. So in Synapse, what code did I run? Let me go ahead and let me show that to you. Where did Synapse go? 1 second. I'm not able to see the tabs properly. Okay, here it is. Here is Synapse. And not to get data from a particular file, I wrote this particular code, right? Same code, I can go ahead and run it in Databricks. It's just that this time the path will be different. Path doesn't exist. Okay, I don't have to mention DBFS here. I just have to mention from file store button because it will automatically go to DBFS. Okay. Here it says path must be absolute. Hmm, what change I have done? Path is absolute. Path must be absolute. A legal argument exception. Okay. If path is absolute, right? What other change do I have to do? Let me mention the path here. Let's see. So the point that I'm making is the same code that you can run in Synapse, same you can run in Databricks as well. Okay. Now in Synapse, if you wanted to go ahead and do visualization, there was a chart option available, and that uh, output that was shown to you in the form of table, you are also able to visualize it. Okay. But what if you want to customize this visualization? You could do that in Synapse. So if you, instead of bar chart, you want line chart, you want different columns to be used to create this chart, you can go ahead and do that. Similarly, here in Databricks also, you will be able to do it. So here there is a plus button. You can try to create a visualization from this output. Okay, whatever visualization you want. So let's suppose you want a bar chart. Okay, wherein you will try to group by on species column, and on the x-axis, let me have sepal length. Okay, and so like that, you can go ahead and create a chart over here. So here, I guess what I want to do is I want to find average of, okay, or count. Mm, no, not count distinct. To find average. Okay, your average option is not available to me. I wanted to find the average sepal length of every species. Okay, fine. But count distinct. Okay, for every species is the distinct count of Setosa. Okay, this is strange. Hmm, is there? Any mistake I'm doing while making code? This is fine. Instead of this, what if I have a scatter plot, a simple scatter plot, forgets grouping by species and everything. Let's suppose sepal length column on the x-axis, sepal width column on the y-axis. Okay. So like this, you can go ahead and make graphs. So I always feel that Databricks is more better as compared to Synapse in terms of making graphs. It has more options to make graphs. So Databricks is more better than Synapse, and compared to Databricks, Fabric is even better. Okay. So uh, if I compare the visualization making capability, yes, in Synapse you do have the option, but there is Databricks, which is better than Synapse, and then there is Fabric, which is even better than Databricks. So visualization options are there. Anyways, I just wanted to prove to you that the same codes that you can run on Synapse, same you can run on your Databricks as well. Okay, just like in Synapse using a Spark pool, you can run code in multiple languages. Similarly, here also you can do that. Here also you will be able to do that. Okay. It says not found. Why? Create. Mm,
Percentile.
hmm. But here in Databricks, even this percentage, single percentage will work. Created it using Python language. And here, no. Uh, 1 second. Checked. What wrong am I doing? I have my view created over here, and it's saying no such view exists. Table of view not found. It's the same spelling, right? We have not defined. Okay, fine. Now you can see I'm able to run the code. So the point that I was making was that the same code I can run in Synapse, same I can run in Databricks as well. Okay. So we were talking about how to do data engineering with code. There are three services that allow you to do that. One is Databricks, other is Synapse, third is Fabric. I have shown you demo of Databricks and Synapse. Let me show you demo of Fabric. Okay. So in case of Fabric, how would you do it? Let's see. So you have to go to the Fabric portal. So I'll say app.fabric.microsoft.com. We'll go to the Fabric portal. And now let's see how to do data engineering with code. I've already shown you how to do data engineering without code. But if you want to do data engineering with code, then how you can do it. Let's see. So here I'll go to my workspaces that I was working with earlier in the morning. And now let's suppose I want to create a new notebook. Okay. And now what I want to do is I want to go ahead and write some code in the notebook, just like how I was able to write code in notebook of Synapse, just like how I was able to write code in notebook of Databricks. In a similar way, I want to write code in notebook of Fabric as well. Okay. Now remember, Fabric has capacity to store data within itself. Okay. Unlike Synapse, which does not have capacity to store files. So Synapse required help of storage account resource. Then came Databricks days. The Databricks has its own native system, but it's not recommended for production purposes. So is there a tool which can store data within itself and it's also recommended for production purposes? It's Fabric. In Fabric, you can store your files. Okay. If you want to store your files, you can go ahead and store it. And Also, it's recommended for production purposes. Okay. Anyways, let me go ahead and let me show to you how you can do that. So, what I will do is I will simply go ahead and try to first upload my data, and that data will be stored in a lake house, right? So I guess Prabhakar had used the term data warehouse, then data lake. Okay. So what is data lake? Data lake is a place where you can store all type of files, right? So Prabhakar, in case of Synapse, did it have its own data lake? No.
No, no.
For data lake purpose, that means for storing files, Synapse took help of an external resource, right?
Correct.
Whereas Fabric has data lake inbuilt into it.
Mm-hmm.
Okay, so it does not require help of any external resource. So how to do that? How to upload data in a data lake over here? Let me go ahead and let me show that to you. So for doing that, you have to click on this plus button, and I'll say I want to upload data in a data lake, also known as lake house. Here it is. It says lake house, you can store data. Fine. So let's store data. That lake house, I will call it any name I want to give. I'll call it webinar lake house. Let's go ahead, run it. Let's run. And what I'll do is in my data lake, also known as lake house over here, I'll try to upload my data. So remember, Synapse doesn't have capability to store data within itself. So it uh, took help of an external resource to store files. Databricks had capability to store data within itself, and it has its own file system called DBFS, but it's not recommended for production scenarios. Reasons I mentioned to you. So is there a resource? Sorry, is there a tool which can store data within itself, and it is also recommended for production purposes? Yes, that tool is called Fabric. So let me go ahead and let me upload my files. I'll go ahead and upload my files over here. The name of the file is iris.csv. Okay, let's wait over here for that file to get uploaded. I hope it is uploaded now. Okay, that file is uploaded called iris.csv. Now, what I will do is I will try to go ahead and load this particular file to a table so that I can query from it. Okay, so that I can query from it. So just like in your Fabric, so just like in your Synapse and your Databricks, you can run code in your using your SQL pool, using a Spark pool, but you had to configure those pools. In Synapse, I had to create my SQL pool, I had to create my Spark pool. In Databricks, I had to create my SQL pool, I had to create my Spark pool. In Fabrics, you don't have to create it yourself. It will automatically be created for you behind the scenes. Okay. So even here, you will have your SQL pool, you will have your Spark pool. Okay. It's just that here you don't have a concept called serverless pool. So unlike in Synapse, unlike in Databricks, where you had a concept called serverless SQL pool, here the concept of serverless will not exist. Okay. So here in Fabric, you have your SQL pool and Spark pool, but all of those are dedicated pools only. Okay. Anyways, so let's suppose I want to work with SQL pool, wherein I will write code in SQL language. How to do it? Let's see. So what I will do is, um, in order to write code in SQL language, I need a SQL table. So I will convert the data inside of this file to a SQL table. So I'll say load the data from this file to a new table. I'll give any name to the table that I like. Depends on me. And with this, a SQL table will be created. Once it's created, then I will be able to go ahead and run SQL code on it. Okay. I'll be able to then go ahead and run SQL code on it. Let's wait over here. Let's wait for the table to get created. The creation is in progress. So let's wait till then. You can see the table is getting created. Okay, the table is created. Now you can go ahead and run query on it if you like. So let me do one thing now. Mm, Here, what I want to do is um, I want to go ahead and query using SQL. So here at the top, there is a drop down which you can use to query data from SQL. Let's wait for that option to fully get enabled. We'll wait over here. And then we'll be able to query the data using SQL language. Behind the scenes, SQL pool will be used, but you don't have to create that SQL pool. Fabric has already created it. Okay. So over here, basically right now, when you see this buffer happening, what is happening? Basically, it is trying to configure that uh, SQL pool behind the scenes. Okay. So we don't have to do anything. Okay. Those pools will be created by Fabric automatically. Fine. So it's creating. So we'll just wait till then. See, we didn't specifically ask it to create, but it understood that, okay, you have a SQL table created. So you will need a SQL pool also, because maybe you might want to query from that SQL table. So it's creating that SQL pool. We'll wait till then. Once the SQL pool is created, then this option will get enabled and you will be able to query your SQL data using SQL language. Let's wait till then. Let's wait. The creation is still in progress. We'll wait for a few more minutes. The creation is still in progress over here. Okay, till then, I guess we can do one thing, because 1.5 hours have already passed. I guess it's better that I give you a break. Hopefully, during the break time, this option will get fully enabled and then we can come back and try to work with it. Okay. But up till now, guys, I have tried to explain to you how you can do data engineering with code. There are three main services that you can use for that. One is Databricks, other is Synapse, third is Fabric. Out of these three services, I have already given an intro of Databricks and Synapse. Intro of Fabric is still left, which we'll see. But up till now, whatever we have done, has it made sense, guys? Was it understandable? I know it might be too much to understand in one day. Okay. But hopefully by looking at the recording again, it will be more clear to you. But up till now, is it understandable to everyone?
Yes, ma'am.
Yes. Okay. Fine. All right. So let's take a short break. Okay. Hopefully by the time the break ends, this option of querying data using SQL table will get enabled for us. Currently, it's creating a Spark pool in the backend. So that option has not been enabled yet. Fine. Hopefully by the end of the break, it will be enabled. So I'll just start the timer for our tea break. So let's take a tea break of around 15 minutes and we'll be back after that. Till then, I'll just be on mute. We'll come back after 15 minutes.
Participants, there is a small request for the participants to kindly redeem their Microsoft Learning badges, as the badges will expire in few days. And also, you need to redeem it by today or tomorrow itself. Today it would be great. If you could redeem it now, it would be great because you have to showcase it on your Microsoft skilling journey and you can use it for your LinkedIn profile as well. So I just request all the participants to please kindly redeem their badges as early as possible. If you have redeemed the badges, kindly just put a thumbs up in the chat box or just react a thumbs up to the message which I have sent so we can get an intimation.
Guys, please do redeem your badges. Welcome back to the session, everyone. Hope all of you guys are back after the break. Now, let's resume. So, guys, we were trying to understand the overview of Fabric. To be specific, we were trying to understand how to do data engineering with code, and there were three main services for that. One was Databricks, second was Synapse, and third was Fabric. Out of these three services, we have already covered Databricks service and Synapse service. Now it was time to move on to Fabric. Okay, so I mentioned that just like in your Databricks and Synapse, you have SQL pool, Spark pool. Even in Fabric, you have SQL and pool and Spark pool. But in Fabric, you don't have to create those pools manually. It will automatically be created for you. That's point number one. Second point is that unlike in Databricks and Synapse, where you have concept of serverless pool, here in Fabric, you don't have that. Okay, so whatever pools are created are dedicated pools only. There are no serverless pools. Okay, fine. Now let's go ahead. And it seems that here the option of querying data using SQL pool has not been enabled yet. I'm not sure why. Let me refresh the portal and see whether that works. If not, till then we'll try to do some other task. Let's wait. Okay, fine. Now I can go ahead and show you how you can write code in SQL language if required. So I'll say I want to write a SQL query. Obviously, for this, behind the scenes SQL pool will be used, but you don't have to configure that SQL pool. It will automatically be configured for you. So I'll say select star from iris. And let's see if we are able to run the code inside of it. Sorry, if we are able to get the values inside of this table. And you can see we are able to do that. Similarly, you can write your other analysis code, okay, that you want. Uh, Whatever analysis code it is, using group by, using some other commands, you can go ahead and do that. Okay, so it's up to you. Fine. Now what if you want to go ahead and see some examples? So let's suppose you want to count, um, let's suppose, or let's suppose I want to find the average, I want to count the average petal and sepal length by species, right? That was the task I wanted to do, average petal and sepal length by species. So let me do that, average petal and sepal length by species. So first I'll calculate average of sepal length and I'll round it off up till 2 decimal places. Similarly, I'll do the same with petal length as well. And I'll try to group by on species column. Okay, let's see. I wanted to get the average sepal length and petal length of every species. And hopefully I should be able to do that. I am able to get the average petal length and sepal length of every species. In order to see the column names properly, let me rename the columns over here. I'll try to rename the columns. So I'll say values obtained in this column should be stored in the column called AVG sepal length. Similarly, the values obtained in another column should be stored in a column called average petal length. Hopefully this will be more better. The output will be more readable and it is more readable here. Fine. So like this, you can go ahead and write code using SQL pool. Behind the scenes, SQL pool is used. It's just that you don't have to configure it. It will already be configured for you. Okay. Then coming to Spark pool. Okay. So what if you want to write code using Spark pool? Remember, Spark pool supports writing code in multiple languages. Okay. So whether you want to write code in Python language, then SQL language, there are other languages also that it supports. How to work with Spark pool? So for that, you'll have to work with a file that supports writing code in multiple languages, and that type of file is notebook file. Here, what will happen is whatever code you will run behind the scenes, Spark pool will be used. I'll just wait for that notebook file to launch. Behind the scenes, what will happen is Spark pool will be used. Let's wait. Fine. Behind the scenes, remember, my Spark pool will be used. Okay, fine. Now let's suppose what I want to do is I want to read data from particular file. How to do that? I had already uploaded some data. Let's suppose I want to get the data from that file. How to do it? Let's see. I had already uploaded data in my lakehouse. The name of the file was, I guess, iris.csv. Let's wait here. We'll wait. Let's wait for our data lake to open. Remember, data lake is nothing but the place where you can store your files. Synapse doesn't have its own data lake, but Fabric does. Okay, let's suppose you want to go ahead and read the data inside of this file called iris.csv. How to do that? Let's see. So I'll just go to properties and try to get the path of this. Okay, so it's okay. Here I can mention the full URL. That's also fine. Even the relative path will work because by default, Fabric will try to search for data in its own data lake only. So even this relative path will work. Let me go ahead and let me pass that path. So here I'll just say that I want to read data using Spark library, and that data that I want to read is in is in a file. Which file? CSV file. Let me mention the relevant options. I'll say in this CSV file, I do have a header. I do have a header, and let me load data from this particular file. Let's see if I'm able to read data. Whatever data I'm reading, I'll store it inside of a variable called df. Let me store it inside of this variable df. I'll try to run this code again because earlier the code that I ran did not have this variable assigned called df. Let me just wait. Let me run and let's see the error. What is the error? It says error occurred while loading, bad request. It says nothing called iris.csv. That's unlikely. Everything seems correct. What's the issue? Error occurred. Bad request. Hmm. I feel my code is right. Anything wrong with it? I'll delete it. Try to run it again. Spark.read.format. Want to read data from CSV file. And here I do have header and I want to load data from this particular file. Okay, and I do get a error, same error. What am I missing? Anything wrong in my code? Anything wrong? Bad request. Iris.csv. Let me mention the full path. Let's see. Okay, with full path, it's working well. Okay, anyways. So over here, I have read the data from this file. Let me display the data and then I can go ahead and do analysis on it. Okay. So let's suppose what I want to do is some basic analysis, like let's say I want to find the average sepal length and petal length for every species. So just like I had done it on SQL, I can do the same over here in Python. So I'll say group by the species column. And I want to calculate average on sepal length and petal length column. Average is one of the aggregate formulas. So I want to perform aggregate on sepal length and petal length column. So on sepal length column, I want to perform this aggregate called average. Then on sepal width, or sorry, on petal length column, I want to perform this aggregate called average again. Okay, let me mention that. Fine. And hopefully I'm not doing anything wrong over here. Let's go ahead and let's just show the output of this code. Am I able to calculate average sepal length and petal length for every species? Let's see. I am able to do that. Fine. So over here, the point that I'm making is just like in Synapse, just like in Databricks, you have SQL pool and Spark pool. Similarly, in Fabric also, you have your SQL pool and Spark pool. It's just that in Synapse and Databricks, you had to create those pools, you had to configure those pools. Whereas in Fabric, you don't have to configure those pools. Fabric already takes care of that configuration for you. It doesn't wait for you to create the pools. It automatically creates it for you. Okay, so this makes it more user friendly. Okay, that's why even though Synapse was launched in 2019, after that people complained that although Synapse is quite good, but there was still some complaints in Synapse. That's why Microsoft launched Fabric. Okay, in the year 2023. Fine. So as years have progressed ahead, the data engineering tools have become better and better. All right. So with this, I wanted to show you the capabilities of these data engineering tools. I have shown you the how to do data engineering without code as well as how to do data engineering with code. Same task that I did uh, on Fabric, same I replicated on other data engineering services as well. Okay. So if we talk about data engineering without code, there are three main services: Data Factory, Synapse, and Fabric. And the same task that I did on Data Factory, same I did on Synapse, same I did on Fabric. Okay, and we tried to understand the differences between these three services. Then after the lunch break, we tried to do data engineering with code, and for that there are three services. One is Databricks, another is Synapse, third is Fabric. Okay, so same task that I did on Databricks, same I did on Synapse, and same I did on Fabric as well. We just try to understand the difference between these three services. So the main difference is that in order to do data engineering with code, there are two main types of pools available: SQL pool and Spark pool. So in case of Databricks and Synapse, you have to configure those pools, whereas in case of Fabric, you don't have to configure it. There are other differences as well, but this is one of the main differences. Anyways, so with this, we have covered overview of these data engineering services. But once we do data engineering, guys, once we do data engineering, then after that, what is the purpose? So data engineering is just the process of converting the data in a format that can be used for further tasks. Which further tasks? Analysis task. There are two main types of analysis you can do. One is historical analysis, wherein you have some historical data. On that historical data, you do analysis. For example, I had historical data of iris flowers. On that data, I tried to do some basic analysis. So that's is historical data. Okay, wherein you have data of uh, things that happened previously, and based on that, you're trying to analyze information. Okay, the second type of analysis is predictive analysis, for which you have to create models, for which you have to create AI models. Okay, either using machine learning approach or using deep learning approach. So what we'll do is, let's see how you can do predictive analysis on these tools, on these data engineering tools. Okay, but remember, for making predictive analysis, for doing predictive analysis, you need models. Okay, AI models. So let's go ahead and let's understand what is AI, how to create a AI model from scratch. So even though you don't know anything, let's suppose you don't know anything about AI, still, how do you be creating a AI model? Let's go ahead and let's understand that. Let's start from scratch. Okay, what is AI? Everybody by now would know that AI stands for artificial intelligence. But what is it? So guys, AI is nothing but a set of tools that is used to get inferences through predictions. Okay. AI is nothing but a set of tools that is used to get inferences through predictions. Inference means insights. So you might ask me that, Smith, okay, how to get these inferences through predictions? So guys, we do it by using something called a AI model. What is a AI model? A AI model is nothing but a statistical representation of a real world process. I know the definition might have sounded complex to you, but don't worry, I will simplify it for you. In order to simplify it, let me take help of an example. So let's suppose I have information of some of the houses in my locality. Okay, I have information of some of the houses in my locality, and here is the information shown to you on your screen. Let's suppose I have information about area of the house in square feet, and I also have information about the price of the house. So let's assume the first house in my locality had an area of 100 square feet and the price of the house was 1 crore. Okay. Second house in my locality had an area of 200 square feet and the price of the house was 2 crore. Third house in my locality had an area of 300 square feet and the price of the house was 3 crore. Now, I have a question for each and every one of you. Let's suppose I have information about a fourth house. The area of that house is 350 square feet, but I don't know the price of that house. So, according to you, can you guys predict the price of this house? Everyone? What would be the price of this house? Anyone with the prediction? What would be
3.20.
3.20
3.20.
or
Oh,
3.5?
no. 3.5 plus 2, 3.70.
Why? For 350 square feet, the price will
Yeah,
be somewhere around
3.50.
3.5 crore, right?
3.50.
Correct?
Yes, yes.
Right. Somewhere around that. Perfect. So, as you rightly mentioned, buddy, that according to you, the price of this house would be somewhere around 3.5 crore. So, you have given me a correct prediction. Okay. I don't remember the name of people who gave it, but whoever gave me the prediction, you have given correct prediction. So, Pradeep, Gulab Rai, there was another student who gave me correct prediction. But in order to arrive at this prediction, you guys use some mathematics in your brain. You guys use some statistics in your brain, right? That's exactly what a AI model also does. A AI model also tries to use statistics or tries to use mathematics to simulate what would happen in the real world. Okay. So just like you guys use mathematics, you guys use statistics to simulate a real world process. Similarly, a AI model will also tries to use mathematics. It will also try to use statistics to simulate what would happen in the real world. Now, in order to create a AI model, there are two main notes that you need to remember. First important note or first important point is that in order to create a AI model, you need some data, and that data needs to have some rows and some columns. You might ask me that, Smith, we have heard that we can create a model on image data as well. And image data by default is not in the form of rows and columns. You are right. We can create model on image data, But if we want to create a model on that image data, even that image data has to be converted into row and column format. So whatever data you will be using to create a model, that data needs to be converted into row and column format before creating a AI model on it. Note number two is that there are only two useful type of columns in your data. Two useful type of columns in your data. First useful type of column is called a feature column. Second useful type of column in your data is called a target column. What is the difference between the two? Well, a feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. Let's understand the difference between a feature column and a target column with the help of an example. Let's suppose I have um, some data with me, and here is the data shown to me on my screen. Okay, so I have a question for you. Let's suppose I want to predict on price column. Then price will be which type of column? Remember, there are only two useful type of columns in your data. First useful type of column is called a feature column. Second useful type of column in your data is called a target column. Feature columns are those columns that help me to predict. Target column is that column that I want to predict. If you want to predict on price, then price will be which type of column, guys? If you want to predict on price, then price will be which type of column?
Feature.
Sure, or something else? See, feature column is that column that helps me to predict. Target column is that column that you want to predict. So if you want to predict on price,
So I want square feet and city. That means two columns comes under feature.
and what about price?
Is a target. What is going to be. So target is
Perfect.
price.
Correct, correct. So as the student has rightly mentioned, sorry, what is your name, buddy? It's not coming in this chat. Who is speaking?
Prabhakar.
Okay,
Prabhakar.
Prabhakar. Okay, okay. Fine. So as Prabhakar has rightly mentioned, price will be my target column. And since square feet and city help me to predict price, they will be called my feature columns. Perfect. Okay. Now, let's learn about the different approaches to create a AI model. But before we do that, I'll do a quick revision of what we have learned up till now. First, we started off by understanding what is AI. We said that AI is nothing but a set of tools that is used to get inferences through predictions. You might ask me that, Smith, how do we do that? How do we get inferences through predictions? So we do that by using something called a AI model. What is a AI model? It's nothing but a statistical representation of a real world process. In simple words, we'll try to simulate a real world process using some statistics, using some mathematics. Now, before creating a AI model, there are two important notes that you need to remember. First important note is that for making any AI model to work, you need some data, and that data needs to have some rows and some columns. Second important note is that there are only two useful type of columns in your data. First useful type of column is called a feature column. Second useful type of column in your data is called a target column. Feature columns are those columns that help me to predict. Target column is that column that I want to predict. So let's suppose on this data, if I want to predict on price, then price will be my target column. And since square feet and city help me to predict price, they will be called my feature columns. Now, there are different approaches to create a AI model. First is the approach of machine learning. Second is the approach of deep learning. Let's understand the overview of these approaches first. Okay. And in order to understand the overview, I always use this analogy of a knife and a machete. Okay. So, uh, let me ask you guys a simple question. So, Prabhakar, let me ask you a simple question, not related to AI, just a simple question that if you want to cut a simple object like a potato or a tomato or an apple, in that scenario, which tool will you ideally use, a knife or a machete?
Knife.
Knife. Although you can use both, but ideally for cutting simple objects, you will choose a simple tool like a knife. On the other
Correct.
hand, buddy, in order to cut a complex object like a coconut, which tool will you use, a knife or a machete?
Machete.
Correct. So what you are saying is for simple objects, you will use simple tool like knife. For complex objects, you will use complex tool like machete. Similarly, guys, if you are working on simple data sets, you will use the simple approach, which is the machine learning approach. For complex data sets, you will use the complex approach, which is the deep learning approach. Now, how will I know whether a data set is simple or complex? Well, if the relationship between feature and target is simple to understand, then the data set is a simple data set. Whereas if the relationship between feature and target is complex to understand, then the data set is a complex data set. For example, let's suppose I have data wherein I have one feature column and one target column. In my feature column, I have information about pixel values of images. And in my target column, I have information about the sentiment of the person in that image. Let's suppose in the first row, I have pixel values of first image. Remember, pixel values will be between 0 to 255. So let's suppose we have a 3 by 3 image wherein it has 3 pixels in width, 3 pixels in height. Each pixel will have a value between 0 to 255. Okay, something like this. Each pixel will have a value between 0 to 255. So let's suppose in the first row you have pixel values of first image. Correspondingly in the target, you have information about whether that image, whether the person in that image was happy or sad or neutral. Let's suppose in the first image the person was happy. Let's suppose in the second image the person was sad. Let's suppose in the third image the person was sad again, and so on. So now, if you look at the relationship between feature and target over here, is it simple for you to understand or is it complex for you to understand? Here, the
Simple.
relationship between, yes, what are you saying? Someone said
Simple.
something. Simple.
Yeah, simple.
Okay.
Mm.
For example, you look at this image. Have a look at pixel values and tell me whether the person in the image is happy, sad, or neutral. Will you be able to do it, buddy? No, right? Just by looking at pixel values. If somebody just shows you pixel values and tells you that, okay, look at pixel values and figure out whether the person in the image is happy, sad, or neutral, you won't be able to say that, right, buddy? Am I correct? We won't be able to do that just by looking at pixel values. If you look at these pixel values are between 0 to 255. Looking at pixel values, how will we know whether the person in the image is happy, sad, or neutral? Right, Prabhakar? Agreed, buddy?
Correct.
Yes.
No, we cannot because see, it is a camera, right? So happy, sadness is something different. Pixels is different. I don't know how
Huh.
to. I'm
Correct.
not
I'm just
sure.
saying that if somebody just shows you pixel values, let's suppose in your TV, instead of showing colors instead of pixels, they show you pixel values.
Uh-huh.
Okay.
No, no,
Behind the scenes,
not
your
possible. Yeah,
correct.
yeah, not
So
possible to find out the. Yeah,
perfect. So can I say, buddy, that here the relationship between feature and target is complex to understand.
correct.
And in that scenario, buddy, if the data set is complex, we'll use the complex approach, which is the deep learning
Deep
approach.
learning.
Perfect. So as Prabhakar has rightly said, on simple data sets, we'll use simple approach, which is the machine learning approach. For complex data sets, we'll use complex approach, which is the deep learning approach. Okay. So when I asked you guys that, okay, in order to cut simple objects like a potato or a tomato or a apple, which tool will you use, a knife or machete? You guys correctly mentioned knife. One of the reason was that it is simple to implement. Similarly, guys, remember machine learning approach is simple to implement, whereas deep learning approach is complex to implement. So a person who is new to AI will find machine learning approach a lot easier as compared to deep learning approach. What was another reason, Prabhakar, when I asked you a question that in order to cut a simple object like a potato or a tomato or apple, which tool will you use, a knife or machete? You chose knife. One reason was that it is simple to use, simple to implement. Can I say, Prabhakar, second reason was cost?
Yeah, definitely.
Correct? That knife will be more cheaper. Similarly, guys, machine learning approach is more cheaper. If you create a AI model using the machine learning approach, you will see that machine learning approach has comparatively less number of mathematical computations, because of which the computation cost will be low. Whereas deep learning approach has comparatively more number of mathematical computations, because of which the computation cost will be high. Okay, fine. Then let's go ahead and let's talk about one more point. So, Prabhakar, in terms of pure cutting efficiency, which tool will be better, a knife or machete, in terms of pure cutting
Machete.
sharpness? Perfect.
Machete.
Machete will be better. Similarly, buddy, here in terms of pure model performance, deep learning approach is better. So if you create a AI model with deep learning approach, you will see that that model has comparatively better accuracy in terms of predictions as compared to machine learning approach. That is what is usually observed in general. Okay. So with this, we have understood the different approaches to create a AI model. Now let's understand the different types of AI model that you can create. There are many types of AI models that we can create, but 95% of the work done in the AI industry is done on these two types only. So we'll focus on these two types for now. First is supervised learning model. Second is unsupervised learning model. What is the difference between the two? Well, a supervised learning model is a model wherein the data that you're using has features and target both. Whereas unsupervised learning model is a model wherein the data that you're using only has features but doesn't have target. Then, supervised learning models are further divided into two types. First is classification model. Second is regression model. What is the difference between the two? Well, a classification model is a model wherein the target column has finite set of possibilities, whereas a regression model is a model wherein the target column has infinite set of possibilities. Let's understand the difference with the help of an example. Let's suppose I have a target column with me called dice roll. And what I'm doing is I'm playing a game of dice with my friends. And whatever value I get after rolling the dice, that value I'm storing it in this column. So let's suppose when I roll the dice for the first time, I get the value 4. Then when I roll the dice again, I get the value 6. Again, when I roll the dice, I get the value 2. Again, when I roll the dice, I get the value 2 again, and so on. Okay. So let's assume that this column called dice roll is my target column. Now in this target column, how many different possibilities do we have? Or in simple words, when we roll a dice, how many possibilities we have, guys? Yes, Prabhakar, you are saying something? When we roll a dice, how many possibilities we have?
How many faces are there? That is a possibility of. Suppose it has 6 faces, and
Correct.
dice has. So it is
Correct. So,
depends on. Yeah.
right. So in general, dice, as you have correctly mentioned, have 6 phases. So that means in general, a dice would have 6 possibilities, right? If I roll a dice, it would have 6 possibilities, correct? I can only
Correct.
get one out of 6 values. Either I can get the value 1, 2, 3, 4, 5, or 6. I cannot get anything else apart from that. So if
Yes.
dice roll column is my target column, then as Pradeep and Prabhakar have rightly mentioned, that in this target column, I would have only 6 possibilities. That means in my target column, I would have finite set of possibilities. And if in my target column, I have finite set of possibilities, then the model will be called a classification model. Let's take one more example. Let's suppose I have a target column with me called gender, wherein I'm storing the gender value of every participant in today's meeting. Let's suppose the first participant that entered today had a gender of female. Next participant that entered today had a gender of male. Third participant that entered today had a gender of male, and so on. Now let's assume that this gender column is my target column. Now in this target column, do I have finite set of possibilities or infinite set of possibilities? Of course, finite set of possibilities. And if your target column has finite set of possibilities, in this scenario, my target column has only 2 possibilities. Either the target column value will be male or female. So if in your target column, you have finite set of possibilities, then your model will be called a classification model. Let's take one more example. Let's suppose I have a column with me, a target column with me called stock price, wherein I'm mentioning the price of the stock after every day. Let's suppose on the first day, the price of the stock was 99.48 rupees. On the next day, it was 98.9 rupees. On the next day, it was 100.4714 rupees, and so on. So if stock price column is your target column, then in this target column, do you have finite set of possibilities or infinite set of possibilities, guys?
Infinite.
Perfect. So as Prabhakar has rightly mentioned, infinite set of possibilities. And if your target column has infinite set of possibilities, then your model will be called a regression model. With this, we have completed basics of AI. We have learned that in order to create a AI model, there are two approaches. One is the approach of machine learning, other is the approach of deep learning. So let's use the machine learning approach today and let's create a AI model. Okay. What is a AI model, by the way? It's nothing but a statistical representation of a real world process. In simple words, we'll use some statistical formulas to simulate a real world process. Or in other words, we'll apply some statistical steps to simulate a real world process. Those statistical steps can also be termed as statistical algorithm. So we'll apply a statistical algorithm to simulate a real world process. Now you can either develop your own statistical algorithm or you can use some statistical algorithms already available in the market. Let me show you one such statistical algorithm already available in the market called multinomial naive Bayes. I will show you one of the statistical algorithms already available in the market called multinomial naive Bayes. So you might ask me that Smith, this algorithm is used to create which type of AI model, supervised learning model or unsupervised learning model? Remember guys that it is used to create a supervised learning model. That means it will only work only if the data that you are using has features and target both. Then you might ask me that Smith, there are two type of supervised learning models, classification model and regression model. So this algorithm is used to create which type of supervised learning model? So guys, remember that it's used to create a classification model. That means it will only work only if your target column has finite set of possibilities. Otherwise it will not work. Okay, fine. So let's suppose I want to apply this algorithm to create a AI model. Now, in order to create a AI model, you will need some data, right? So let's suppose you have data of emails. Okay. And using that data of emails, you want to create a AI model that predicts whether the email that you have received is a normal email or whether the email that you have received is a spam email. Okay, fine. So let's suppose you have data of emails. You have data of emails. In that data, let's suppose you have one feature column, one target column. In your feature column, you have information about text of emails. So let's suppose in the first row, you have text of email one, and that email, let's assume, was a normal email. Okay. I hope my voice is audible. I've got a message saying my internet connection is weak. Prabhakar, is my voice audible, buddy?
Yes, yes, we are able
Yes.
to hear
Okay.
you.
Perfect. Fine. So let's suppose I have data of emails. In that data, I have two columns. One is my feature column, another is target column. Okay. So let's suppose in my feature column, I have text of emails. So let's suppose in the first row, I have text of email one, and let's suppose that email was a normal email. Let's suppose in the second row, I have text of second email, and let's suppose the second email was also a normal email. Okay. Then let's suppose in the third row, I have text of third email. And let's assume that the third email was a spam email. Okay. So like this, I have data of total 12 emails. Let's assume out of those 12 emails, let's assume that 8 emails belong to normal category and 4 emails belong to spam category. Now, what I want to do is I want to build a model that can predict whether my email that I'm receiving is a normal email or whether the email that I'm receiving is a spam email. And I will do that by applying this algorithm called multinomial naive Bayes. So what I'll do first is based on count of unique words in normal emails, I will create a histogram based on count of unique words in normal emails. We will create a histogram. Okay. So here you might say that Smith, I only see histogram of 4 unique words. In reality, normal emails would have thousands of unique words. Well, you're right. In reality, normal emails would have thousands of unique words. But here, just to keep the example simple on these slides, I have assumed only 4 unique words. That let's suppose in your emails, you only had 4 unique words. Okay. Fine. So based on count of unique words in normal emails, we have created a histogram. It seems from this histogram that the word dear is occurring a total of 8 times in normal emails. It is occurring a total of 8 times in normal emails. The word friend is occurring a total of 5 times in normal emails. The word lunch is occurring a total of 3 times in normal emails. The word money is occurring a total of 1 time in normal email. Based on this information, can you guys tell me what will be the probability of obtaining the word dear in a normal email? What will be the probability of obtaining the word dear in a normal email? So the word dear is occurring 8 times. So
8,
8
8.
divided by total number of words in normal emails. And here, Prabhakar, how many total number of words we have? Dear is occurring 8 times, friend is occurring 5 times, lunch is occurring
17.
3 times, correct, and money is occurring 1 time. So total number of words in normal emails is 17. So probability of obtaining the word dear in a normal email will be 8 by 17. Similarly, probability of obtaining the word friend in a normal email will be 5 by 17. Probability of obtaining the word lunch in a normal email will be 3 by 17. And probability of obtaining the word money in a normal email will be 1 by 17. Now, just like I have done this with respect to normal emails, let me do the same with respect to spam emails. So based on count of unique words in spam emails, I have created a histogram. So it seems from this histogram that the word dear is occurring 2 times in spam emails. The word friend is occurring 1 time in spam email. The word money is occurring 0 times in sorry, the word lunch is occurring 0 times in spam email. The word money is occurring 4 times in spam email and so on. Okay. Pradeep, you have a doubt? Pradeep has a doubt? You want me to unmute you? No? Okay, fine. You want me to unmute you? Then let me know. I can unmute you. You have mentioned a message, so okay. You can let. Okay, you want me to unmute you? Okay, fine. I'll unmute you. Pradeep, let me search for your name. Here it is. Let me allow you my mic access. Okay, so you'll be able to unmute yourself. Fine. So now let's go ahead. So just like I done just like I performed the earlier step with respect to normal emails, let me do the same thing with respect to spam emails. So based on count of unique words in spam emails, I have created a histogram. It seems from this histogram that the word dear is occurring 2 times in spam email. The word friend is occurring 1 time in spam email. The word lunch is occurring 0 times in spam email. The word money is occurring 4 times in spam email. So let's go ahead. Let's calculate probability of these words occurring in spam emails. So probability of the word dear in a spam email will be, what will it be? Pradeep, can you let me know? What will it be, buddy?
Yeah, 2 by
Correct.
7.
7. Perfect. Then probability of obtaining friend in a spam email will be 1 by 7. Right? Then so on. Like this will calculate for every word over here. Probability of obtaining the word lunch in a spam email will be 0 by 7, which will be 0 only, and so on. Probability of obtaining the word money in a spam email will be 4 by 7. Like this, I'll calculate their probabilities. Now, earlier, Pradeep, if you remember in my data, I had a total of 12 emails. Out of 12 emails, 8 are normal and 4 are spam. So, Pradeep, what is the probability of obtaining normal emails in my data set? Probability of obtaining normal emails in my data set?
8 by 12.
Perfect. And probability of obtaining spam emails in my data set will be 4 by 12.
4 by
Perfect. So as Pradeep has rightly mentioned, probability of obtaining normal emails in my data set will be 8 by 12. And probability of obtaining spam emails in my data set will be 4 by 12. Now, let's suppose I've received an email having these two words written in it. Dear friend. Okay. Now I want to know to which category this email belongs to, whether it belongs to normal category or spam category. So what I will do is I will first calculate the probability of this email belonging to normal email. Then I will calculate the probability of this email belonging to spam email. And whichever probability is higher, let's say probability of this email belongs to normal category is higher, then I will conclude that this email belongs to normal category. On the other hand, probability of this email belonging to spam category is higher. Then I will conclude that this email belongs to spam category and so on. Fine. So let's calculate probability of this email belonging to normal category as well as spam category. Okay. So probability of this email belonging to normal category will be probability of obtaining normal emails in my data set multiplied by probability of obtaining the word dear in a normal email multiplied by probability of obtaining the word friend in a normal email. I already know the probability values. I'll just substitute them into this equation. And at the end, I get an answer of 0.09. Similarly, let me calculate probability of this email belonging to spam category. Remember guys, here we are calculating probabilities using a formula called knife Bayes formula. And knife Bayes formula was developed in 1970s, more than 5 decades back. And in this formula, it's not necessary that when you calculate probability values, the probability values would sum up to 0. It's not necessary. I understand that in the new age probability based formulas that you would have seen up till now, whenever you calculate probability values, they always sum up to 0, right? But with knife based formula, it's not so. Okay, it's not necessary that whenever you will calculate probability values, they would sum up to 0. Anyways, here let's go ahead. Now that I have calculated probability of this email belonging to normal category, let me calculate probability of this email belonging to spam category. So I will have probability of obtaining spam emails in my data set multiplied by probability of obtaining the word dear in a spam email multiplied by probability of obtaining the word friend in a spam email. I'll just substitute the probability values into this equation and at the end I'll get an answer of 0.01. So now I have the probability of this email belonging to normal category and the probability of this email belonging to spam category. Which probability is higher? Obviously, probability of this email belonging to normal category is higher. That's why I will make a prediction that this email belongs to normal category. So that's how this algorithm will make prediction. Okay. So that's how this algorithm called multinomial knife Bayes works and makes prediction. Guys, did the theory of this algorithm make sense? Did the theory of the algorithm make sense to all? Is it clear? Theory part at least. Implementation part,
Yes.
I'll show it to you. Yes, okay. Now, let me show you the implementation part. Okay, so how to implement. So what I'll do is I'll go ahead and I can implement it in any tool that allows me to write code in Python language. So even Synapse allows me to write code in Python language. Even Databricks allows me to write code in Python language. Even Fabric allows me to write code in Python language. Let me choose Fabric. And what I'll do is first I will upload some data here. Create a new folder called 1 second. I don't want to upload a folder. I want to create a new subfolder called AI data. In that subfolder, I will upload my data. Let's suppose my data is inside of a CSV file. So let me upload that CSV file. In this CSV file, I have information about tweets written by either Donald Trump or Justin Trudeau. So what I want to do is I want to build a AI model that predicts whether my tweet is written by Donald Trump or whether my tweet is or whether this tweet is written by Justin Trudeau. Okay. So I want to build a model that can predict the author of the tweet, that whether the author is Donald Trump or Justin Trudeau, either one out of these two. So how will I be able to create such a model? Let's go ahead and let's see. Okay. Remember guys that in order to implement a supervised learning model, okay, going forward, whenever you want to go ahead and implement a supervised learning model, in order to implement a supervised learning model, you will have to follow a total of 8 steps. What are those 8 steps? Let me show them to you. The first step, okay, is that remember that in order to implement a supervised learning model, you have to follow a total of 8 steps. First step is that your data should be clean. First step is that your data should be clean. It should not have any missing values. It should not have spelling mistakes. Okay. After that, what you need to do is you need to ensure that whatever data you have, from that data, you will extract the feature columns and target columns separately. Then the third step is to make sure that the features should be of numeric nature. Okay, the features should be of numeric nature. The fourth step is to make sure that the features should have some rows and some columns. Then the fifth step is to split the data into two parts, training and testing. Now, what is the purpose of doing that? Let's understand. Let's suppose I have some data with me, having one feature column, one target column. In my feature column, let's suppose I have information about number of pregnancies. And in my target column, I have information about gender. Let's suppose I have data of some people with me. Let's suppose the first person having two pregnancies was a female. The next person having zero pregnancies was also a female. The next person having, uh, let's suppose one pregnancy was a female. The next person having one pregnancy was a female again. And the next person having zero pregnancies was a male. Now, what I'll do is this data I'll divide it into two parts, training and testing. So let's suppose I decide that 60% of the data should go into training, remaining 40% should go into testing. Total, I have 5 rows over here. 60% of 5 is 3 rows. So that means 3 rows will go into training and the remaining 2 will go into testing. Although the selection of rows in training and testing is random, but let's suppose even in random selection, what happened was first 3 rows went into training, remaining 2 went into testing. Remember, the model will only get trained on the training data set. Okay. And in order to test the model, you will introduce the testing data set. While testing the model on the testing data set, what you will do is, while testing the model, you will hide the actual target values of the rows in the testing data set. And you will ask the model that, okay, look at the feature column values of the testing data set and predict the target. Okay, and predict the target. So the model might say that, okay, for the first row in the testing data, the target column value is female. For the second row in the testing data, again, the target value will be hidden. So model will say, looking at feature column value, that, okay, for the second row in the testing data, the target column value is female again. Then you will cross check whether the predicted target column values match with the actual target column values. It seems over here that prediction was done on 2 rows, and out of 2 rows, only for 1 row, correct prediction was done, right? Only for this 1 row, correct prediction was done. Oh, fine. So your accuracy will be 0.5. In percentage terms, we'll say your model is 50% accurate on the testing data set. Anyway, so that's the idea behind dividing the data into training and testing. Then the sixth step is to make sure that our features should be on the same scale. Okay. But this should only be done on algorithms where you feel that a column having higher range of values would dominate a column, would dominate a column having lower range of values, would dominate a feature column having a lower range of values. If that is going to be the case, then In that scenario, you will make sure that if feature columns do not have same range of values, that means if they are not on the same scale, then you will convert them to the same scale. But in our current algorithm, multinomial naive Bayes, that's not the case. In this algorithm, it's not the case that a column having higher range of values would dominate column having lower range of values. So that's fine. In our current algorithm, step number 6 can be ignored. Moving on to step number 7, which is to make sure that the features, or I should say train the model on the training data set. And then the eighth and last step is to test the model on the testing data set. So these are the 8 steps that you have to implement in order to create any supervised learning model. Okay, fine. Let's get the data. So we'll create a model. For that, we need some data. So I can use the pandas library for that. Not necessary to always work with Spark library. I can use any Python library. You can create a model with different libraries in Python. Different libraries support creation of a model. It's up to you which library you want to choose. Anyways, here I'll just go ahead and get the data from my CSV file. And let me mention the path of that data. My data has been uploaded. Let me get the path of that data and paste the path in my code. What happened? I received an error. Why is that error? Let me mention the ABFS path just so that there is no issues related to uh, the retrieval of the data. Now it should work correctly. Fine. Now I obtain the data. Now what I will do is simple. I just want to implement these steps. First step is to make sure that data is clean. So it should not have any missing values, any spelling mistakes. Let's go ahead and let's check whether our data is clean or not. Let's check for spelling mistakes first. On checking for spelling mistakes, we observe that our data doesn't have any missing values. The first column has 0 missing values, second column has 0 missing values, third column has 0 missing values, fourth column has 0 missing values. So the data doesn't have any missing values. I have checked for spelling mistakes earlier in my data. My data does not have any spelling mistakes as well. So I can declare that my data is clean. Second step is to make sure that we extract the features and targets separately. Let's do that. So here in my data, what I want to do, I want to build a model that can predict the author of the tweet. So the author column will be my target column, right? And this last column, which contains text of the tweet, this will be my feature column. Fine. So let me extract my feature column and target column separately. I'll go ahead and get my feature column and target column separately. So the author column will be my target column, but the last column that contains information about the text of the tweets, it will be my feature column. With this, we have completed step number 2. Moving to step number 3, which is to make sure that features should be of numeric nature. So guys, I have one feature column with me, and even that feature column is non-numeric. If you have a look, that feature column is non-numeric. So if it's non-numeric, I have to convert it to numeric. How to do that? Let's see. Okay, how to do that? Let's see. So if you have a non-numeric column with you, first you need to check whether that non-numeric feature column is of discrete nature or continuous nature. First, you have to check whether that non-numeric feature column is of discrete nature or continuous nature. If it is of discrete nature, then there are many techniques that you can use to convert that non-numeric feature column into a numeric feature column. One of the techniques that you can use is one-hot encoding. On the other hand, if your non-numeric feature column is continuous in nature, there are many techniques you can use to convert that non-numeric feature column into a numeric feature column. One of the techniques that you can choose is count vectorizer technique. So let me go ahead and check whether my non-numeric feature column is discrete in nature or continuous in nature. What do you think, guys? My non-numeric feature column, is it discrete in nature or continuous in nature? Here I have information about text of tweets. Is there finite set of possibilities or infinite set of possibilities? Anyone? Prabhakar, Pradeep, anyone else?
Discrete nature.
Yes, what are you saying, Pradeep?
Discrete in nature.
Discrete, correct. So if our non-numeric feature column is discrete in nature, now discrete means finite set of possibilities. If it's finite, you tell me how many possibilities of tweets we have. Are you sure it's discrete?
No, no.
No, right? So here we have infinite set of possibilities, right? Anybody can write any tweet,
Yes, yes.
right? So we have infinite set of possibilities. So the column is continuous in nature. See, discrete column means a column having a finite set of possibilities. Continuous column means a column having infinite set of possibilities. So here my feature column has infinite set of possibilities. So it's a continuous type of column. If it is so, there are many techniques I can choose from. One of the popular technique that I can choose is count vectorizer technique. So let me show you how it works, how count vectorizer technique works. So let's see the working of count vectorizer technique over here. So through the whiteboard, I'll try to make you understand this technique called count vectorizer. Let's suppose I have a non-numeric feature column with me called tweets. And what I want to do is I want to convert that non-numeric feature column values to numeric values. Okay, fine. So let's see how to do that. Let's suppose I have this non-numeric feature column called tweets, in which I have two tweets. First tweet is saying that cricket is a sport. Second tweet says that sport of cricket is a exciting sport. Okay, fine. So let's go ahead and let's see how to convert this non-numeric feature column into a numeric feature column. So let's see the steps of count vectorizer. First step is to make sure that um, you figure out the number of unique words. You figure out the number of unique words in the non-numeric feature column. Second step is to create a new column. Create a new column for every unique word. Third step is to fill in the column values based on the count of those unique words across each row. Fine. So first step of count vectorizer is to figure out the number of unique words in the non-numeric feature column. So here how many unique words we have? Let's see. Cricket is a unique word. Is would be another unique word. A would be another unique word. Sport would be another unique word. The next word is not unique as it has already occurred previously. The next word off would be another unique word. The next word is also not unique as it has already occurred previously. The next word is also not unique as it has already occurred previously. The next word called A is also not unique as it has already occurred previously. The word exciting is a unique word. The word sport is not unique as it has already occurred previously. So in total, we have 6 unique words, right? So we'll create a column for every unique word. The next step of count vectorizer is to create a column for each unique word. So since there are 6 unique words, we'll create a column for every unique word. First unique word is cricket. We'll create a column for that. Next unique word is, so we'll create a column for that. Next unique word is A, so we'll create a column for that. Next unique word is sports, so we'll create a column for that. Next unique word is off, so we'll create a column for that. Next unique word is exciting, so we'll create a column for that. Okay, fine. Now, what we need to do, we need to fill in the column values based on the count of those unique words across each row. So in the first row, the word cricket is occurring how many times? One time. In the first row, the word is occurring how many times? One time. In the first row, the word A is occurring how many times? One time. In the first row, the word sport is occurring how many times? One time. In the first row, the word off is occurring how many times? Zero times. In the first row, the word exciting is occurring how many times? Zero times. Coming to the second row now. In the second row, the word cricket is occurring how many times? One time. In the second row, the word is occurring how many times? One time. In the second row, the word A is occurring how many times? One time. In the second row, the word sport is occurring how many times? Two times. In the second row, the word off is occurring how many times? One time. In the second row, the word exciting is occurring how many times? One time. With this, the non-numeric column values have been converted to numeric column values. In the process, we got more columns than what we had before, but that's just how count vectorizer works. Okay. So this is how count vectorizer works. Now that we have covered the theory, let's see its implementation. So in order to implement it, I'll need help of a class which I will import. From sklearn folder, there is another folder called feature extraction. From that folder, there is a file called text. And from that file, I will import this class called count vectorizer. After importing this class, I'll go ahead and call it. With this, the count vectorizer technique will wake up. Once it has woken up, what I'll do is I will apply the count vectorizer technique on the non-numeric feature column. Let me apply it. With this, the non-numeric values will be converted to numeric values, but I'll get more columns than what I had before. And that's just how count vectorizer works. With this, step number 3 done. Moving on to step number 4, which is to make sure that features should have some rows and some columns. So let's check whether the features have some rows and some columns or not. On checking, we observe that the features do have 400 rows and 2528 columns. So they do have some rows and some columns. You can see count vectorizer created more than 2500 columns. One column for every unique word detected. Okay. With this, step number 4 done. Moving on to step number 5. Step number 5 is to split the data into training and testing. Okay. Let's go ahead and let's see how to do that. In order to do it, I'll need help of a function which I will import. From sklearn folder, there is a file called uh, model selection. And from that file, I will try to import this function called train test split. Let me go ahead and let me call this function. First, I'll pass my features. After that, I'll pass the target. Then I'll mention the ratio in which I want to divide the data into training and testing. Let's suppose 80% of the overall rows I want in. Let's suppose 80% of the rows I want in training, the remaining 20% I want in testing. Since I want 20% of the rows in testing, that is why to the test size parameter, I'll pass a value of 0.2, which indicates that 20% of the overall rows should go to testing. Okay. Now, while doing this train test split, I will have some issues. To be specific, two main issues. Let's see those issues, and after that, I will show you the solution for it. Okay. Let me introduce the issues. By the way, remember that the selection of rows into training and testing is random. It's not like always the first few rows will go into training dataset or the last few rows will go into training dataset. No, the selection of rows is completely random. Okay. So maybe sometimes first few rows could go into training. Sometimes the last few rows could go into training. Sometimes the middle few rows could go into training. Selection of rows is completely random. Now, because of this random selection, there are two main issues that will occur. Let's see those issues first. After that, I will show you the solution for it. Okay. So let's suppose in my data, I have 5 rows. Out of those 5 rows, let's suppose that first 3 rows are good and the remaining 2 rows are bad. Now, why would I call a row a good row or a bad row? Let's understand. In order to understand it, I will take help of an example. Let's suppose, Pradeep, you are the principal of a school and you want to design benches for first standard students. Okay. You are the principal of a school, Pradeep, and you want to design benches for first standard students. Now, as a good principal, Pradeep, can I say what you will do is you will try to survey the height of first standard students, and based on their average height, you will give the appropriate order to the carpenter. Can I say that? Yes.
Yes.
Right?
Yes.
Okay. So let's suppose you did that. You're trying to survey the height of first standard students. One student in the class had a height of 2.1 feet. Next student had a height of 2.05 feet. Next student had a height of 2.15 feet. Fourth student had a height of 7.1 feet. Next, last student had a height of 7.2 feet. These are the height of students in first standard. Now, over here, Pradeep, can I say the fourth and fifth students in the class can be called outliers or odd man out? Because having students who are so tall in first standard, it's very rare, right?
Yes.
So fourth and fifth students over here are odd man outs or outliers. Now, including outliers in our calculation, will it negatively influence our calculation? Let's see. So as a principal, what you are thinking is you want to design benches for first standard students. For that, you are thinking, let me survey the height of first standard students. I'll calculate the average, and based on the average, I'll give the appropriate order to the carpenter. So let's calculate the average over here. What does it turn out to be? So on calculating the average, we observe that the average is equal to 4.12. Average is equal to 4.12. So now now you will go to the carpenter and tell the carpenter that create benches assuming that average height of students is 4.12 feet. Now Pradeep, because of that, can I say the first three students in the class will suffer because the benches that you have asked to design will be too high for them, correct?
Yes. It will be
Right?
difficult. Yeah.
So that means Pradeep here including outlier values in the calculation negatively influences the calculation. Similarly, if we have outlier values in our data, it will then negatively influence our model's calculation as well. Okay. So that's why when I said that in my data, let's suppose I have 5 rows, first 3 rows are good, remaining 2 rows are bad. When I say bad rows means rows that could have outlier values because outlier values negatively influence the model's calculation. Okay, fine. Remember the selection of rows and training and testing is random. Okay, it's not fixed. It's completely random. Now, because of that, there are two issues that will come up. Let's see those issues. So let's suppose 60% of the overall rows you want in training and the remaining 40% you want in testing. Okay. 60% of 5 is 3. So 3 rows would go into training, remaining 2 would go into testing. Although the selection of rows in training and testing is random, but still even in random selection, there is a possibility that maybe, okay, the first 3 rows went into training and the remaining rows went into testing. Now, Pradeep, when I train you, can I say the quality and quantity of example both matters, right? If I give more examples, the better your performance will be, right? And if I give you good quality of examples, the better your performance will be. Agreed? Correct?
Agreed.
Correct. Same applies to the model. To the model also, the more examples you pass for training, the better the model's performance will be. Remember, for the model, every row in the training data set is treated as an example. The more rows you pass in the training data set, that means the more examples you pass for training, the better the model's performance will be. So apart from quantity of examples, the quality also matters. So if you pass good rows in training, your model's performance will be good. If you pass bad rows in training, the model's performance will be bad. Okay. Fine. So let's suppose you pass good rows in training. In that case, what will happen is the model's performance will be good. And let's suppose you got a accuracy of 100%. So you are very happy. You call your boss and tell your boss that boss, I have made a model that is giving me 100% accuracy. Your boss is also happy. So your boss says that, okay, come to the office the next day and show me the model. So you go to the office the next day. But next day, when you go in the office in front of your boss, is it possible that when you run the code again, is it possible, guys, that I get different rows in training and testing? Possible or not, Prabhakar?
Possible.
Possible, right? So tomorrow when you go in front of your boss, you might get different rows in training. Maybe you get these rows in training. Now, among the rows that you have selected in training, majority of the rows are bad rows. So your performance will be bad. Okay, let's suppose tomorrow you get an accuracy of only 50 or let's say 0% or some lower other number, 0% or 50%. So your boss will be very unhappy. Your boss will say, are you fooling me or what? Yesterday you told me your model is giving 100% accuracy. Now your model is giving 50% accuracy. What is happening? See, you are not fooling your boss. But why did this difference in accuracy come? Because yesterday you had different rows in training and testing, and today you have different rows in training and testing. To avoid this, can I say we need to make sure that every time when we run the code, we should get same rows in training and testing, especially in corporate environments where there is a need to reproduce the output. Let's suppose that the development team has developed a model. Now the QA team wants to test the model. So in order to replicate the model performance, the development team might claim that they have got 90% accuracy. For the QA team to also get the same accuracy, the QA team also needs to ensure that whatever rows was selected in training and testing dataset by the development team, same rows should be selected in training and testing dataset by the QA team. How to ensure that? How can that be possible? Well, what you can do is you can use this concept called seeding. Okay, let me explain that concept over here. So I'll open a different coding tool. Doesn't matter which coding tool I open. I just want a coding tool that allows me to write code in Python. Okay, so let me explain you the concept of seeding. And let me show to you how it will work. Let me explain to you how seeding will work. So let's suppose I'm importing this random function which will generate random value between 0 and 1. And every time when I will call it, you will see what it will do. It will generate a random value between 0 and 1. But now let me use the concept of seeding. Okay. So what I will do is I will open the seed function. I will import the seed function and let me use this concept of seeding. So the idea is that if you plant a seed of apple, only apple tree will grow. If you plant a seed of uh, chiku, only chiku tree will grow, right? Similarly, guys, if you pass a seed value, you will always get the same reproducible output every time. So which seed value to pass? Remember, you can pass any seed value of your choice. However, while passing seed value, take care of 2 points. First is whatever seed value you pass should be a numeric value. Second is whatever seed value you pass should be a number without decimals. Okay. And third is whatever seed value you pass should be a positive value. So positive numeric value without decimals. So Prabhakar, give me any positive numeric value without decimals of your choice. Positive numeric value without decimals. Positive numeric value without decimals of your choice. Anyone can provide it to me.
2.
2. Okay. Fine. Have a look, buddy. Here, Pradeep, you have mentioned a value of 2. With this, have a look. The random value that is generated now will be the same throughout. Every time when I'll try to generate a random value, every time I'll get the same number. So can you see, buddy, with that with the same seed value, you are getting the same random number generated every time, correct? Right, Pradeep? With the same seed
Right.
value, we are getting the same
Yes.
random number generated. Let's suppose if you say pass a seed value of 10, then with the same seed value of 10, same random number will get generated every time. With same seed value of 10, same random number will get generated every time. So with same seed value, same random number gets generated. So the idea is that if the development team is claiming certain accuracy, for the QA team to test out that accuracy, the QA team wants to ensure that whatever rows development team used in training and testing, same rows the QA team also uses in training and testing. For that, they can use the concept of seeding. So the idea is whatever seed value the development team passed, let's suppose the development team chose a seed value of 10. Then the same seed value they have to communicate to the QA team so that the QA team also uses the same seed value of 10 and they also end up with the same rows in training and testing. Okay, so one issue was there which we solved using seeding. There is another issue now. Let's see that issue. Okay, let's suppose I have a target column with me. Let's suppose I have a target column with me. In that target column, I'm storing the gender value of every participant in this meeting. Let's suppose the first four participants that entered this meeting had a gender of male. And the remaining four participants that entered this meeting had a gender of female. Now, what I want to do is, let's suppose some of the rows I want to have in training, the remaining rows I want to have in testing. Okay. So although the selection of rows in training and testing is random, but it could happen that maybe the first four rows go into training, the remaining four rows go into testing. Now remember the model only trains on the training data set. In the training data set, I have passed four rows or four examples. And here, Pradeep, among the rows that you have passed in the training data set, is there even a single example where the target value is equal to female? Among the rows that you have passed in the training data set, is there even a single example where the target value is equal to female? No, right?
No.
No, right? So the model will not know that such a target value called female exists. Why? Because remember, the model only trains on the training data set. In the training data set,
Yeah.
I have passed four examples. In none of those four examples, there is even a single example where the target value is equal to female. So how will the model know that such a target value even exists? If it doesn't even know that it exists, how will it make prediction on it? It will never be able to make prediction on it. Okay, it will never be able to make prediction on it. So there's a big issue. How to solve this issue? We'll solve it using the concept of stratification. We'll solve it using the concept of stratification. So what stratification says? It says that the proportion of target values present in the original target column present in the original target column should be similar to proportion of target values present in training and testing datasets. Okay, fine. So here, Pradeep, in the original target column, there are two unique values, male and female. What is their proportion, Pradeep? What is their proportion in the original target column? How many times the value male is occurring? 4 out of 8 times. So 50% of the times, right? Correct?
Right. Correct.
Right. And the value female is occurring also 4 out of 8 times. That means 50% of the times. So what
Yeah.
stratification says is that in the original target column, if male and female are occurring 50% of the times, then in training data set also male and female should occur 50% of the times. In testing data set also male and female should occur 50% of the times. Okay. So now what would happen is not only will satisfy the train test split ratio, will also satisfy the stratification ratio. Let's see. So now maybe these four rows could get selected in training. I'll mention the row values selected in training. And the remaining rows could get selected in testing. I'll mention the row values selected in testing. So as per stratification, if in the original target column male and female are occurring 50-50% of the times, then in training data set also male and female should occur 50-50% of the times. In testing data set also male and female should occur 50-50% of the times. Here have a look. Is male female occurring 50-50% of the times? Yes, in training data set. In testing data set is male female occurring 50-50% of the times? Yes. So not only we have satisfied our train test split ratio, we have also satisfied a stratification ratio. With this, did a problem get solved? Let's investigate. Earlier, a problem was in the training data set, there was not even a single example where the target value was equal to female, because of which the model did not know that such a target value even exists. If it does not know that it exists, how will it predict it? It would never be able to predict it. But now in the training data set, you have passed enough examples of both the kind of target values, male and female. So now your model will be aware about both. If your model is aware about both, it will be able to predict on both the type of target values. Okay. So we'll apply stratification over here. Remember, stratification needs to be applied on target column values. It needs to be applied on target column values. Remember that. Fine. So I'll just mention over here, please apply stratification on target column values, and that's it. With this, first, these features will be split into two parts. You will get feature train and feature test. After that, the target will be split into two parts, and you will get target train and target test. With this, okay, here I'm having an error. Why is that issue coming? Let's see. Let's see. Okay, I guess it's random state. That's the name of the parameter to which we pass a seed value. Fine. So the name of the parameter was wrong. I corrected it, and after that the code worked. With this, step number 5 done. Step number 6, which is related to scaling, but it only needs to be done on algorithms where you feel that a feature column having higher range of values would dominate a feature column having lower range of values. But in multinomials naive Bayes algorithm, it's not going to be the case. So step number 6 will be ignored in our current algorithm. Moving on to step number 7. Step number 7 here is to train the model on the training data set. In order to train the model, you will need a statistical algorithm. Either you will develop your own statistical algorithm or you can use a statistical algorithm already available in the market. Let me use a statistical algorithm already available in the market called multinomial naive Bayes. In order to implement it, I'll need help of a class which I will import. From sklearn folder, there is a file called naive Bayes, and from that file, I will import this class called multinomial NB. I'll go ahead and call this class. With this, the algorithm will be ready. And once the algorithm is ready, then what I will do is using the algorithm, I will train the model on the training data set. So out of the 4 things that I got in train test split, which things belong to training data set? Feature train and target train belong to training data set. So let me go ahead and pass that over here. Feature train and target train. With this, step number 7 done. Okay. The model will get trained. You can see it will get trained shortly. Once the model is trained, then what we'll do is we will test the model on the testing data set, which is the last step, 8th step. Test the model on the testing data set. So we'll just wait for the model to get trained fully. And after that, we'll test the model on the testing data set. Let us just wait for the model to get fully trained. Let's wait. Okay, now the model has fully trained. Now let's proceed. Now let's move on to a last step, which is to test the model on the testing data set. So which things belong to testing data set? Out of the 4 things that I got in train test split, feature test and target test belong to testing data set. So let me pass that over here. With this, I will get an accuracy score between 0 and 1. Okay. So let's suppose the model made predictions on 80 rows of the testing data set, out of which 76 rows correct prediction was made. So your accuracy will be 0.9. That means your model is 90% accurate on the testing data set. For a model to be acceptable, the accuracy should at least be greater than or equal to 0.7. Here, let's see whether it's the case, whether it's greater than or equal to 0.7. Yes, it is. So it's an acceptable model. Once you feel the model is acceptable, then you can use it for predictive analysis, right? So once you have done your data engineering, then that data can be used for two things. One is historical analysis, second is predictive analysis. So let's make prediction using the model. So I want to make prediction that if I've received a tweet saying that CNN is fake news. So guys, who is more likely to make this tweet? If you follow geopolitics, you would know this. Who is more likely to make this tweet, Donald Trump or Justin Trudeau? Donald Trump or Justin Trudeau? Who is more likely to make this tweet? Anyone who follows geopolitics? They would know this. Out of Donald Trump and Justin Trudeau, who is more likely to make this tweet? Gulab Rai, what do you think? Donald Trump or Justin Trudeau? Anyone? No one? It's Donald Trump, right? As Gulab Rai
Trump.
mentions in the chat, right? Even as Pradeep mentions, it's Donald Trump. Let's see if the model thinks the same. Okay. Let's see if the model thinks the same. So for that, before making predictions on the model, you have to take care of two things. One is whatever changes were done on the features, same needs to be done on the data that you want to predict on. That's point one. Second point is the number of columns in features should match with the number of columns in the data that you want to predict on. In the data that you want to predict on. Okay. So here, let's see what first point is whatever changes were done on the features, same needs to be done on the data that I want to predict on. So I got my feature at step number 2, right? After step number 2, what change has been done? In step number 3, any change in its values? Yes. In count vectorizer, there was a change in feature column values, right? So same count vectorizer, I will apply it on my data that I want to predict on. Okay. But if you have a close look here, in order to apply, I'm using the transform method. Earlier in count vectorizer, I used fit underscore transform, but now I'm only using transform. Why? Well, here when I applied fit underscore transform, what did the word fit do? It applied step 1 of count vectorizer. Step 1 of count vectorizer was to scan the non-numeric feature column and find out the unique total number of unique words. Then the transform method in count vectorizer implemented the remaining two steps of count vectorizer, which is step 2 and step 3. Okay, but the fit method implemented step 1. It figured out the total number of unique words. Based on that, that many columns were created. Okay, but if you have a look, if on the data that I want to predict on, if I apply fit again, what will happen is then it will find out that okay, there are 4 unique words. That means 4 columns needs to be created. Then the number of feature columns would be around 2500, and the number of columns in the data that I want to predict on will only be 4, and it would not match. So to avoid that, what I'm telling count vectorizer is based on the scanning that you had done earlier, you had found 2500 columns. Based on that only do the transformation. Okay, based on that only do the transformation. So I'm not applying fit method again. I'm avoiding scanning of my non-numeric feature column. I'm avoiding that my system figures out the total number of unique words in this non-numeric feature column. Okay. So because if it finds the total number of unique words, it will say that, okay, there are 4 unique words. So 4 columns would get created. then the number of columns in features would be around 2500, and the number of columns in the data that I want to predict on would be 4, which would not match. So to avoid that, I'm not applying fit again over here. I'm only applying transform. Fine. With this, step 1 will be done. Over here, I have a error. I guess the previous code was not executed, but now that error will vanish. Okay, with this point 1 done, after count vectorizer, I don't think any change was done on features. So that's it. Step 2 was that the number of columns in features should match with the number of columns in the data that I want to predict on. The number of columns in features is 2528, and the number of columns in the data that I want to predict on is also 2528. That's it. Point number 2 also done. Now I can use my model to make prediction. We know that this tweet is more likely to be made by whom? Donald Trump or Justin Trudeau? Donald Trump. Let's see if the model also thinks the same. And yes, the model does think the same. Let's make the prediction a little bit more exciting. Let's take a real tweet from Justin Trudeau's Twitter account. Let's take a real tweet from Justin Trudeau's Twitter account. And to make it more interesting, I will take his tweet in French language. He has a habit, Justin Trudeau has a habit, then whenever he'll make a tweet, he will create 2 drafts of it. One will be in English language, another will be in French language. Okay. So let me take his tweet in French language and let me pass it to the model. I'll go ahead and pass this to the model. Hopefully in the data that I have used to train the model, I have passed some French tweets. Okay. So hopefully my model should know that if it's a French tweet, it should be written by Justin Trudeau. Okay. Let's see if that's the case. What does the model think? And over here, the model thinks that the author of the tweet is Justin Trudeau. So up till now, correct predictions, right? But still, this is not a market ready model. By market ready model, I mean this is not a model that I will dare to sell to any client. Why? Because I feel the model could still do mispredictions. Why do I feel that it could still do mispredictions? Two main reasons. One was the choice of the algorithm. I chose a very basic algorithm called multinomial naive Bayes. There are much better algorithms as compared to this. Okay. So one is the choice of algorithm. I used a very basic algorithm. Second is the number of rows in the training data, the number of examples in the training data. Remember, the more rows you pass in the training data, the more examples you pass in the training data, the better the model will be. Here, hardly in my data I had 400 rows, out of which 80% went into training, 20% went into testing. So 80% of 400 is 320. So 320 rows went into training, which is very few rows in training. My model should have thousands and thousands of rows at least, if not in lakhs. The model should have thousands and thousands of rows in the training data. The more rows you pass in the training data, the better the model will be. So although up till now the predictions are correct, but still I feel the model could still do mistakes. Okay, so I will not dare to sell this model to any client. Okay, two main reasons. One is the choice of algorithm. Second is very less training data used for the model. All right. With this, our agenda of today is complete. Gulabrai says, let's do a quick revision of all the 8 steps. So yes, Gulabrai, in order to implement any supervised learning model means a model that has feature column and target column both in the data. So if you have such a model, in order to implement it, there are 8 steps. First step is that data should be clean. So clean means your data should not have any missing values, any spelling mistakes. Here we checked for missing values and we found out that the data did not have any missing values whatsoever. As far as spelling mistakes were concerned, I already checked for spelling mistakes. There were no spelling mistakes as well. Coming to step number 2, which was to extract feature columns and target column. Here I wanted to create a model that predicts the author of a tweet. So author column was my target column. And the last column that it contains information about text of the tweet, that column was my feature column. Then third step was to make sure that feature should be of numeric nature. So here I have one feature column which was non-numeric. So since it was non-numeric, I converted it to numeric. In order to convert a non-numeric feature column into a numeric feature column, first you have to check whether that non-numeric feature column is of discrete nature or continuous nature. If it's of discrete nature, you have multiple techniques to choose from. One of the technique is one-hot encoding. If it's of continuous nature, there are multiple techniques to choose from. One of the technique is count vectorizer technique. Okay, so since our non-numeric feature column was continuous in nature, we applied count vectorizer technique. Fine. After this, step number 4, which was to check whether the features have some rows and some columns. And yes, the features do have 400 rows and 2500 columns. Step number 5 was to split the data into training and testing. And I did that. 80% of rows I put it into training data set. 20% of the rows I put it into testing data set. But while doing this train test split, remember the rows that are selected in training and testing are selected randomly. Because of that random selection, there were two issues that came across. So we saw those two issues. After that, we identified the solution for it. One issue was solved using the concept of seeding. Okay. And the second issue was solved using the concept of stratification. After that, we moved on to step number 6. But remember, step number 6 should only be done on those algorithms where you feel that a feature column having higher range of values will dominate calculation over a feature column having lower range of values. But in our current algorithm, multinomial naive Bayes, that's not going to be the case. So step number 6 we ignored. Moving on to step number 7, wherein we trained the model on the training data set. So in order to train a model, you will need a statistical algorithm. Either you can develop your own algorithm or you can use an algorithm already available in the market. Here I use the algorithm already available in the market called multinomial naive Bayes. So I called that, so in order to implement it, I imported the class for multinomial naive Bayes. I call that class so that the multinomial naive Bayes technique wakes up. Once it has woken up using that algorithm, I train the model on the training data set. With this, step number 7 was done. Then I tested the model on the testing data set. Okay. So in my testing data set, how many rows do we have? So out of 400 rows, 20% of the rows are in testing data set. 20% of 400 is 80. So there are 80 rows in the testing data set. So prediction will be done on all those 80 rows. While making prediction, the target values of the rows in the testing data set will be hidden. So the model will be asked that, okay, look at the feature column values of the testing data set and predict the target as per your own opinion. Remember, during prediction, the actual target column values of the testing data set will be hidden. So while making prediction, the model will be asked to look at the feature column values of the testing data set and make the prediction for all rows in the testing data set. So let's suppose there are 80 rows in the testing data set, out of which for 76 rows correct prediction was done. That means the accuracy would be 0.9, right? In percentage terms, you would say that the model is 90% accurate on the testing data set. Fine. So here in our case, the model was around 92% accurate, which was good enough. Okay. Once that is done, then we can use the model to make predictive analysis, to make predictions. So here I had a tweet and I tried to predict the author of the tweet. And up till now, it seems that the model was correctly able to predict the author. So here, Golabra, with this, I have tried to revise the steps that you wanted. Was this what you wanted or something else? Let me know if there are any
Smith,
other doubts. Yes.
Smith, for testing, I think it went on biased, right? Because we are sending the data in a biased way to get the 90% success.
Huh, you mean that currently
Yeah.
this mode of testing is not that reliable because you're only testing on one data set and maybe in that data set there are easy rows to predict. Just like for example, let's suppose you are the head of a company, Prabhakar. You want to
Mm.
hire one software engineer. Now, let's
Mhm.
suppose one software engineer will come to you and say that, Prabhakar sir, I have attempted a coding exam in which I got 100 out of 100 marks. Just based on that
Mhm.
one exam, will you accept that candidate?
No.
No. So
Perception, many things
correct.
like that.
So what you are saying is maybe that exam was easy. That's why he got full
Mhm.
marks. Just like
Mhm.
that, you are saying that maybe in the rows of this testing data set, there were easy rows to predict.
Okay.
That's why the
To
performance
me,
was good.
yeah.
Correct.
But
So,
to get the
huh.
same response, we are choosing a only positive test cases and sending to model. So it looks to be a or biased result, right?
No, no, not positive case cases. Why only positive? I didn't get.
20%, 20% of the
Huh,
data you
that's just
took.
performance, right? Sorry,
Mhm.
that's just a proportion.
Mhm.
But that
Mm.
doesn't mean positive scenario or negative
Mhm.
scenario.
Mhm.
Any
Okay.
20% of rows could go in testing, right?
Yeah.
But still,
Yeah.
there is a danger, Prabhakar, that maybe those rows that got selected in testing were easy rows.
Mm.
That's why the performance was good. That's why,
Right.
Prabhakar, in machine learning, you have a concept for that as well.
Mm.
Okay. And
Yeah.
it's called cross validation.
And however, I'm listening for the first time this modeling, so
Huh.
I'm not aware. But okay, I think I need to go into the
Correct.
concept. Then I'll understand why this kind of a way you choose. Anyway,
Correct.
that's good. Good for eye opener. Nice.
Correct. Right.
Mm.
So in this lecture, guys, we just wanted to show you the overview of these data engineering tools, especially to talk about Fabric service. And uh, I thought that just before diving into Fabric service, it would be better to show you a comparison of Fabric service with other data engineering services. Okay. That how other data engineering services work, how Fabric service try to improve on that. Okay. Fine.
Data
Golab Rai says,
engineer,
huh?
Smith, data
Yes.
engineer. Then what is the role of data scientist? Some two kind of roles generally happens in the business the
Correct.
openings. One is the data engineer, one is the data scientist. What is the difference in between both?
Correct. So data engineer would just stop after uh, performing either ETL task or ELT task.
Mm-hmm.
Whereas what a data scientist would do, a data scientist would perform the role of a data engineer
Mm-hmm.
as well as the data scientist would try to analyze the data by either doing historical analysis or predictive analysis. So
Okay.
this
By applying
modeling
these
part,
models.
correct, this
Mm-hmm.
modeling part would not be done by a pure data engineer, but it
Yeah.
would be done by a data scientist.
Okay. Okay.
Okay.
Thank you.
So data
Yep.
engineer would probably not do historical analysis or predictive analysis, but data scientists would do it.
Yeah. Thank you.
Yes.
And what are
Welcome.
the competitors for this Azure as of now in the market? Like Data Fabric is the
Correct.
one, and other. What are the
Uh,
other
hmm.
technologies which provide similar kind of a technology on the data
So
side?
correct. So AWS also has similar data engineering services. Okay.
Mhm.
But if you are asking that, is there any other data engineering tool which I have found to be very good as compared to what is made by Microsoft? Up till now, I have not found any. Okay.
Okay.
Yes, there are other competitors like AWS has its own data engineering services, just like Azure has. But
Mhm.
like mostly it's Azure data engineering tools that are widely used in the market. Okay.
Okay.
So
And
yes,
this, if you understand this Fabric and all, I think SSIS, SSRS is not required, right? Because it is covering everything. Fabric is taking care of ETL process and data
correct.
analyzation into
It
Power
is
BI. Then
covering
not the,
everything. Correct.
yeah.
But still
So,
that concept should be known. Okay.
huh. Yeah.
Correct. In this lecture, it was just the overview lecture. So we just tried to understand the overall capabilities of Fabric. We didn't dive into it. Okay.
Okay. Understood. Thank you.
Um, yes. But Prabhakar, the overall capability is understood, buddy, that what Fabric does, how it compares to
Yeah.
other data engineering services. Yes.
Yes. Yes. Yes.
Okay.
Yes. Many
Okay.
concepts. Thank you.
Yes. Okay. Gulabrai says, is it a standard to is there a standard recommendation for train test split? How much proportion to choose? Standard recommendation is 80-20 split, 80% of rows in training, 20% in testing. But it again depends on scenario to scenario. Some people choose 70-30 split, 70% training, 30% testing. Usually the standard that is followed across industry is 80% in training, 20% testing. But again, it depends scenario to scenario. Okay. But if you are asking me for one standard, I would say just remember 80-20 split. Okay. Collabora says Snowflake is growing and they recently. Snowflake is one, right? Correct. But I've not found even Snowflake as a tool or a data engineering service that is better than what is available over here. But you are right, as Gulabrai mentioned, Snowflake is one. Okay. Gulabrai says
Split. Yeah. Please
yes.
go ahead. Go ahead. Go ahead. No, Gulab Rai,
Yes.
you answer Gulab Rai's question.
Yes. So Gulabrai says this is about the training data, but what about model performance? So you are talking about accuracy, right? That what should be the performance of the model in step number 8. So there, what we do is see again. It depends scenario to scenario, but generally, I have not seen a model that was accepted having an accuracy lower than 0.7. But that doesn't mean that okay, anything above that, above 0.7 will be accepted. See, it depends on scenario to scenario. Let's suppose you are building a financial prediction model that predicts whether your transaction in the bank is a fraudulent transaction or not fraudulent transaction. Let's suppose that model gave you a 95% accuracy. So you will say, okay, performance is very good, but still 5% of the transactions it is not predicting correctly, right? And let's assume in a bank, if 5% of the transactions are not predicted correctly, let's suppose there were 5% fraudulent transactions that were not flagged as fraudulent, then it would cause so much loss to the bank, right? So in such a case, even a high accuracy like 95% would not be accepted. So to answer your doubt, it depends on scenario to scenario, buddy. But if you talk to me about one threshold below which we never accept the model is 0.7 accuracy, below which I have not seen any in any scenario where a model having less than 0.7 accuracy has been accepted. Okay, so depends on your use case, and depending on that you will set the threshold for your model performance. Depends on your use case. Correct. So as Gulabrai says, depends on domain to domain, depends on use case to use case. Okay, fine.
Smith, like
Yes,
here, like AI with the data is the model learning creation of AI models using machine learning and other part you said
deep
like
learning.
so that is the starting point of AI driven data modeling.
Exactly. That's the starting point. So this is known as traditional data. This creating we are creating a traditional AI model. This is the
Mhm.
starting point.
Okay.
Nowadays, you would have seen a term being widely used, Gen AI. So
Gen AI,
after
yeah.
traditional AI came Gen AI, which is
Mhm.
built on top of these concepts that you will learn in traditional AI, but it has gone many steps ahead. Okay, but you are
Mhm.
asking that okay, whether this is the starting point? Yes, this is the starting point of traditional AI. Once traditional AI is understood by you, then you should go ahead and understand how Gen AI models are created.
Okay. Okay.
Okay,
Fine.
fine.
Yeah.
All
And
right.
we can have a career build in this area, right? Gen AI, what is that? Traditional
You
then
mean
Gen AI.
webinar on this area?
No, 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 not webinar. Generally, career perspective, once
Uh-huh.
you come into data modeling, like data side, data engineer side, start
Uh-huh.
with this pipeline and all, then AI modeling, then what do we say? Uh, what do we say? Like,
Gen AI.
yeah, Gen AI. So in this,
Correct.
have a line of a career graph, then I think we can make a success in our life careers.
Correct.
This
Correct. And
okay.
right now, even few years back, there were lots of people who had knowledge of creating traditional AI models using machine learning, deep learning, but not all of them were getting hired with good pay. But right now, there's a big demand for people who know how to create custom Gen AI models. So if you know how to do that, then the pay is quite good. Okay.
Mhm.
So yes, the graph that you mentioned is right. First, understand Python programming language, because whether it's traditional AI or Gen AI, it will be based on Python programming language. The main reason is Python has lots of libraries for that, just
Mhm.
no other reason.
Mhm.
After
Yeah.
Python, move on to traditional AI. After traditional AI, move on to Gen AI. Correct.
Okay. Yeah.
Right. Okay. Fine. So guys, with this, we have completed the agenda for today's lecture. I hope it was beneficial for you and you understood how data engineering is done with the different services offered by Microsoft, and how Fabric proves to be useful for you, how Fabric is better as compared to other data engineering services. Okay, fine. So that's it for today, guys. Just a request, please fill in the feedback form before you leave the session.
Yes.
Okay. So I hope,
Yeah.
yes, Anma, you can take it forward.
Yeah. I just wanted to request all the participants to fill the feedback form also. Redeem your Microsoft Learn badges because it's important. Both of it are very important as it will mark your attendance, and also it is important for you to showcase that you have attended this session particularly of 8 hours. So please do that. I'll post both the links once again. and just react thumbs up to that particular message which I'm posting, so I can know that you have successfully redeemed your badge and filled the feedback form. Yeah, thank you.
Yes. So thank you so much, guys, for attending. As Anmay has mentioned, please fill in the feedback and redeem your Microsoft badge. So that's it from my side, guys. Hopefully, we'll meet in some other webinar going forward. Thank you for attending, and bye, guys. Bye, everyone.
Thank you, Smith. Thank you. Thanks so much.
Smith, thank you so much for your guidance. Nice class.
Guys, please ensure that you fill the feedback form before leaving.
Can I get the video of this one, recorded session?
The recordings you will get on our YouTube channel, so you need to subscribe to our YouTube channel for getting to watch the whole webinar again. So just follow us on social media for the relevant updates.